Dehradun, which is a state funding university, government university. And the topic of my talk is Introduction to Queuing Theory. This topic is very much related to our daily life, because if you are paying your bills, and if any other example is if you are moving to any hospital, so you are always interested to serve yourself as early as possible. So this topic is very much related to our life. So during this lecture, we will study, my emphasis will be in following topics. One is what is queuing theory, what is queuing system, then why is it an important tool, then examples of different queuing systems first, so that you can motivate what is the main use of this subject, then the basic structure and components of a queuing system, then the main distributions, this exponential distribution and Poisson process we will study, then terminology and notations which is used in the development of the different models, then Little's law we will study, then steady state birth and death process, and then we will develop different models. Basically we will develop 4 models. Then during the solution of a problem, we will solve these problems, these questions: what fraction of time in each server ideal, what is the expected number of customers, then what is the expected time that a customer spends in a queue, then what is the probability distribution of number of customers present in the queue. And so there are almost 5 or 6 type of questions generally occurs when we are solving a queuing system, and then some application of queuing theory to the system design and decision making. So this is the brief idea about the session. Then now this is a model of a queuing system. Here population represents number of pupils who wants to serve themselves. So they arrive in a system, and then in this system, basically first, if already there are pupils, then obviously there will be a queue. If there are not, there is nobody there, then obviously you will be served immediately. So there is a queue, and then after the service process will start, then you will start in the service. Hopefully, if there are, maybe if you are moving to any banking system, there are single window system, there are lots of servers are available. So that's why suppose there are S number of servers are available. So this is one of the example. Hopefully in sometimes what happens, we are having different phases are also available. For example, in last when the clerical systems was very much used, nowadays computer is used. So you can see your file is on one table, then your file is on the second table. So this is phase, 1 phase, 2 phase, single service, but there are multi-phase. So this type of systems is also used in queuing system. So but the basic tool of a queuing system is customer and service provider. These are the 2 basic tools. The term customer can be man, products, machine, etc. For example, on a production plant, there is no customer, there is basically product. This is the customer. Similarly, the person by whom customer is served is called a server. For example, your internet, this is also a server who will provide you the service. Then now what is actually, this is queuing system. In this is queuing system. Now queuing theory, when we are modeling our queuing system through using mathematical concepts, then this theory is basically known as queuing theory. And in this development process, we are using generally probabilistic concepts. So queuing theory is the mathematical method of analyzing the congestion and delays of waiting in line. Queuing theory examines every component of waiting in line, because our main emphasis is to reduce the length of queue. so that you can provide the service as early as possible to your customers. This is the main emphasis. So queuing theory examines every component of waiting in line to be served, including the arrival process of customers, then service process, and then number of servers, number of system places, and number of customers. In real life application of queuing theory, including providing faster customer service, because this is our main aim, to provide the fastest service to our customers so that they will come next time, otherwise क्या होगा, वो नहीं आएंगे. So real life application of queuing theory includes providing faster customer service, improving traffic flow. Here traffic flow means arrival of customer and his departure. So this is a traffic. So traffic flow efficiently and designing system. Queuing models provide the analyst with a powerful tool for designing and evaluating the performance of queuing system. Here these are the some applications where this queuing theory is applied. For example, in banking sector. अगर आपको याद हो पहले क्या होता था, आपके चेक सुबह दो तो शाम तक का पता ही नहीं है, अभी क्या हो गया, इमीडिएट हो गया है. So banking sector is one of the very effectively, where queuing system is very effectively used. Here in banking system, for example, system is bank, arrival process is nothing but the customers, and service process is basically tailor and other those who are providing the service. Similarly, for example, another is say printers. Here printers में क्या है, आप command देते हो, this is the arrival process. A printer आपका print करता है, that is. और अब तो ऑनलाइन भी हो गए हैं, एक ही प्रिंटर मल्टी चैनल से ऑपरेट हो सकता है वाईफाई के थ्रू. सो दीज आर द मल्टी फेजेस. तो एक ही प्रिंटर में आपकी भी कमांड चल रही है, आपके कलीग की भी कमांड चल रही है. सो वो भी एक क्यूई है, ऑनलाइन क्यूई. सो सिमिलरली इन डॉक्टर्स ऑफिस, पेशेंट्स इज द अराइवल प्रोसेस and treatment by doctors and nurses, this is the service. So these are some of the examples where queuing theory is used. Now the father of queuing theory, because start with the history. The father of this queuing theory is A.K. Erlang, and you have I think listen about the Erlang distribution is also, which is named by this on the. He is basically a Danish engineer who in 1909 experiment with fluctuating demand in telephone, because at that stage there is very few connections are available, very fluctuations are there in telephones. So to reduce the fluctuations and congestion, they used this mathematical modeling, and that mathematical modeling is nowadays known as queuing theory. So he was basically the father of queuing theory. At the end of World War II, his work was extended to more general problems, because his original problem is basically related to the fluctuating problem in telephones. Now after this World War II, this problem is extended to other systems, and now this theory is used in various systems. Now in a queuing model, basically we are having 6 main components. One is the source. Source means person, which source may be finite or infinite. For example, in a in a hospital, basically we are having a finite population. But for example, in Ardhkumb, there are infinite population. कुछ पता ही नहीं है कितने लोग आ रहे हैं, कितने लोग जा रहे हैं. So infinite population is there. Similarly, the arrival process. Arrival process is another very important tool. Then the service time distribution. जो सर्विस प्रोवाइडर आपको सर्विस दे रहा है, सर्विस प्रोवाइडर. देन द मैक्सिमम क्यू सिस्टम कैपेसिटी. जैसे हम लोग यहाँ बैठे हुए हैं, 50 सीटें लगी हुई हैं, दिस इज द कैपेसिटी ऑफ दिस रूम, दिस इज द कैपेसिटी. देन नंबर ऑफ सर्वर्स. फॉर एग्जांपल, आई एम अ सर्वर, यू आर द कस्टमर, सो आई एम अ सिंगल सर्वर. सो दिस इज द नंबर ऑफ, हो भी सकता है कि 3 लोग एक साथ पढ़ा रहे हो, देयर बी 3 सर्वर्स आर देयर. देन द क्यू डिसिप्लिन. Queue discipline is another concept I will discuss in later on. This is, we have shown a very general this example of a queuing theory. Here car is washed in the service station, so there is a queue of cars and trucks. Now the, as I have told earlier, two important tools are there: customer and servers. Customer refers to anything that arrives at a facility and requires service. Example: pupil, machines, trucks, emails, etc. So these are the customers. Then next is the server. Server refers to any resource that provides the requested service. Example: this repair person is one of the example. Runways and airports. So these are the service providers. Calling population, as I have told, population may be finite or infinite. Finite population means if arrival rate depends on number of customers being served and waiting. Example is model 1 of the corporate jet. अब वो तो फाइनाइट है, रनवे पे ऐसा तो नहीं है कि वहां जो है आप कंजेशन कर देंगे, जेट किसी भी एयरपोर्ट पे फाइनाइट ही रहेगा. So this is finite population. Similarly, infinite population model, if arrival rate is not affected by the number of customers being served. And I have taken one example is the earthquake. If the population is infinite. So these are the finite and infinite. Now the system capacity may be limited. For example, the capacity of this room. Unlimited. Example is, for example, this limited capacity example is an automatic car wash. Only has room for 10 cars. So limited capacity. Similarly, unlimited capacity concern tickets sales. जो सेल्स होते हैं किसी भी टिकट के लिए, तो वहां पे तो बहुत सारे लोग चाहते हैं टिकट मिल जाए, तो इनफाइनाइट कैपेसिटी. नाउ सर्विस रेट्स, जो कस्टमर आ रहा है या सर्विस प्रोवाइड करे, दैट इज सर्विस. सो इंटर अराइवल टाइम. सो अराइवल रेट इज बेसिकली द इंटर अराइवल टाइम्स, the time between taken by the two consecutive arrivals. दो कस्टमर्स के बीच का कितना टाइम है. Similarly, service time for service of a single customer, को कितना आप टाइम दे रहे हैं, that is also distributed. So here for inter-arrival time as well as for service time, we are using exponential distribution or Poisson process. So we will take later on this. Then here we have queue discipline. The queue discipline refers to the order in which customers are selected from a queue for service. The most common disciplines are, these are the 5 we have listed here, 5 commonly known disciplines. First is first come first serve, which is written as FCFS. An example is a queue. First figure is basically the first come first serve. जब आप अपना बिल पे करते हैं तो फर्स्ट कम फर्स्ट सर्व चलता है. देन लास्ट कम फर्स्ट सर्व, सेकंड एग्जांपल मैंने नोटबुक्स का लिखा हुआ है. जो बुक सबसे लास्ट में ऊपर रखी जाएगी वो उसको सबसे पहले आप यूज करोगे. लास्ट कम फर्स्ट. अनदर एग्जांपल अगर आपको कोई याद हो, लास्ट कम फर्स्ट सर्व, वो तो यही है. इसके अलावा गोडाउन्स में जो है, गोडाउन्स में जो सबसे लास्ट में आएगा, दरवाजे के पास रखा जाएगा, उसको सबसे पहले निकाला जाएगा. पार्किंग में जो लास्ट में कार आएगी सबसे पहले, तो कभी कभी लास्ट में आना फायदेमंद भी है. नेक्स्ट इज सीरो, सर्विस इन रैंडम ऑर्डर, जो भी आए जिसका भी आए बस. देन जीडी, जनरल डिसिप्लिन. एंड प्रायोरिटी, कस्टमर सेलेक्टेड बेस्ड ऑन सम ऑर्डर ऑफ प्रायोरिटी. अगर आपका कोई रिलेटिव है फटाफट आपका काम कर देगा तो प्रायोरिटी बेसिस इज देयर. सो नाउ इन अ क्यू देयर आर 4 मेजर दिस बिहेवियर. फर्स्ट इज द बार्किंग. कस्टमर बार्किंग मीन्स एक कस्टमर आया, उसने देखा बहुत भीड़ हो रही है, मैं नहीं जाता, दैट इज कॉल्ड बार्किंग. वो बाहर से बाहर ही निकल लिया. सेकेंड इज रिनेजिंग. रिनेजिंग मीन्स वो आया, लाइन में लगा, थोड़ी देर उसने पेशेंस बनाए रखा, लेकिन उसका पेशेंस ने जवाब दिया और वो निकल लिया. सेकंड. थर्ड इज कोल्यूजन. कोल्यूजन मींस इफ 2 or 3 कस्टमर्स कैन कोलैबोरेट, कि भैया ले मेरा काम भी कर देना. जैसे हम जाते हैं ना लाइन में लगते हैं, देखते हैं कोई पड़ोसी तो नहीं है, उसको अपना बिल दिया, भैया तू मेरा भी जमा कर देना, दैट इज कॉल्ड कोल्यूजन. देन द जॉकिंग. जॉकिंग में क्या है, इफ देयर आर मोर देन 1 क्यू. कई बार जैसे लगता है, खासकर बिलिंग में तो बहुत होता था, हम लोग लाइन में लगे रहते थे, दूसरी खिड़की खुलती तो भाग जाते थे सेकंड वाली की, पहले नंबर वहां आ जाएगा, दैट इज कॉल्ड बार्किंग. इफ यू कैन स्विच फ्रॉम वन क्यू टू अनदर क्यू, दैट इज कॉल्ड बार्किंग, जॉकिंग. So this system design. So here first is very common, single channel and single phase. एक ही सर्वर है, एक कोई लगी हुई है, जो आएगा पहले आएगा, फर्स्ट कम फर्स्ट सर्व. सेकंड फिगर इज सिंगल चैनल बट मल्टी फेज. आया, एक फाइल यहाँ उसको साइन करना है, फिर दूसरी टेबल पे जाना है, फिर तीसरी टेबल पे जाना है, मल्टी फेज आर देयर. इन थर्ड हियर, जैसे कि बैंकिंग में है, कोई तो सिंगल है बट देयर आर वेरियस सर्वर्स आर देयर. सो मल्टी चैनल बट सिंगल फेज, एंड मल्टी चैनल एंड मल्टी फेज. कोई है सर्वर भी बहुत सारे हैं और हर सर्वर पे जाने के बाद आपको फिर दूसरे वाले के पास जाना पड़ेगा. So multi-phase, multi-server. So this is 4 systems are there. Now, after modeling a system, queuing model, you are interested to find out the answers of these 7 questions. First is average time that each customer to object spends in the queue. कितना टाइम लग रहा है. एवरेज क्यू लेंथ कितना है किसी सिस्टम का, उसी हिसाब से वो डिजाइन करेगा अपने रूम को, अपनी कैपेसिटी को. देन एवरेज टाइम ईच कस्टमर स्पेंड्स इन द सिस्टम, कितना टाइम वो स्पेंड कर रहा है एक कस्टमर, क्योंकि मोटिव क्या है, उसका एवरेज टाइम जो वो स्पेंड कर रहा है उसको रिड्यूस करना. साथ ही साथ क्या चीज हमें करना है, कॉस्ट भी हमारी ज्यादा खर्च ना हो. फोर्थ क्वेश्चन इज एवरेज नंबर ऑफ कस्टमर्स इन द सिस्टम, कितने रहेंगे एवरेज. फिफ्थ इज द प्रोबेबिलिटी दैट द सर्विस फैसिलिटी विल बी आइडियल. आइडियल मीन्स हमारा सर्वर पे कोई काम ना हो, बीच में वो गैप ले ले थोड़ा, उसके पास कोई काम ना हो, थोड़ा रेस्ट करे, दैट इज कॉल्ड द आइडियल सिचुएशन. यूटिलाइजेशन फैक्टर फॉर द सिस्टम, हियर यूटिलाइजेशन मीन्स द ट्रैफिक इंटेंसिटी. ट्रैफिक इंटेंसिटी मीन्स आना और जाना, ये जो रेशो है अराइवल एंड डिपार्चर, इनका जो रेशो है, दैट इज कॉल्ड द यूटिलाइजेशन फैक्टर. And last is the probability of a specific number of customers in the system. कितने हैं, more than 2 customers रहे उसकी क्या probability है, more than 3 रहे उसकी क्या probability है, that is 7th question. So our interest to find out the sum or all of the questions. Now here, as I told earlier, if you are improving the quality of service, then obviously cost will increase. वो तो increase होगी, एक की जगह दूसरा क्लर्क बिठाना पड़ेगा तो वो भी ज्यादा पैसे लेगा. So the main motive is to reduce the queue length and minimize the cost. दोनों को किसी तरीके से बैलेंस करना कि हमारी कॉस्ट भी हमारे हाथ में रहे एंड सर्विस भी हम बहुत अच्छी दें. हमारा कस्टमर ऐसा ना हो कि उसको आने के बाद यहाँ 1 घंटा वेट करना पड़े, आए थोड़ी देर वेट करे और निकल जाए, कोई दिक्कत नहीं. So this is divided into this points wise. So most waiting line problems are focused on finding the ideal level of service. In most cases, second point, in most cases the service level is something management can control. क्योंकि आपको उसको कंट्रोल करने के लिए तो मैनेजमेंट ही करेगा, वही फंड रिलीज करेगा, वही सब कुछ करेगा अल्टीमेटली. Third is when an organization does have control, they often try to find the balance between 2 extremities. Here 2 extremities are nothing but the queue length and cost. These are 2 extremities. A large staff, fourth point, a large staff and many service facilities generally results in high level of service but have high cost. सर्विस तो बहुत अच्छी देंगे, महंगे होटल में जाएंगे तो महंगा बिल पे भी करना पड़ेगा, सर्विस तो बहुत अच्छी मिलेगी. So fourth, next point, having the minimum number of service facilities keeps service cost down but may result in dissatisfied customer. अगर ज्यादा पैसा खर्च नहीं करेंगे तो आपके कस्टमर की क्यू लेंथ बढ़ जाएगी, आपका कस्टमर क्या होगा, डिससेटिस्फाइड रहेगा कि भैया ये तो अच्छी प्रोवाइड नहीं करता. हम उसी नंबर को यूज करते हैं जो हमें हमारे एरिया में जिसका नेटवर्क अच्छा होता है, जो हमें अच्छी सर्विस प्रोवाइड करता है. Then service facilities are evaluated on their total expected cost, which is the sum of service cost and waiting cost. Here waiting cost is मतलब जो लॉस हो रहा है, वेट करने में भी तो लॉस हो रहा है, that is called waiting cost. So here we have figure based on these number of points. Here if you think on x-axis service level is there, number of servers, and on y-axis cost of opening service facility, operating service facilities. So cost is there on y-axis and service number of servers is basically on x-axis. So if number of servers increase, obviously cost will increase. So this is shown by this cost of providing service, a linear line. A linear line is there. कुछ ऐसा नहीं है जिससे वहीं पे जाके करना पड़ेगा. अच्छा, कर्सर. Okay. So yeah, this is cost of providing service. So if number of servers is less, cost is minimum. If you are improving your service, you are having more servers, then cost of providing service increase. On the other hand, if your number of servers is less, then your waiting cost is high. ज़्यादा wait करना पड़ेगा, server कम होंगे तो. So and if you are improving your service facility, then क्या होगा? Cost of waiting time decrease. So this is shown by this negative exponential distribution here. If you are taking the sum, because total cost is waiting cost as well as the service cost, then you are having the upper curve. This is the total sum, service as well as this cost. And now our interest is to find out this minimum level here. This is the minimum level which is represented by this optimum service level, dotted line. So here aim is to find out this number of servers. कितने हमें सर्वर की जरूरत पड़ेगी कि हमारे कॉस्ट भी मिनिमम रहे, वेटिंग कॉस्ट, और हमारी ऑपरेटिंग कॉस्ट भी मिनिमम रहे. So here our aim is this star. We have represented this by star. Now a system is queuing system basically having two types of states. One is the transient state, other one is the steady state. Transient state means a state which depends upon time, and steady state which is basically free from the time factor. So here we have shown these through these two graphs. Here this blue curve is basically the transient state. However, in first figure red curve is basically a steady state. और जो ट्रांजिएंट स्टेट है जनरली वो किसी भी सिस्टम के ओपनिंग टाइम पे होता है. जब कोई सिस्टम स्टार्ट होता है थोड़ी फ्लक्चुएशंस होती हैं, उसके बाद थोड़े टाइम बाद वो स्मूथली रन करने लगता है. दैट इज स्टेडी स्टेट. सो स्टेडी स्टेट इज बेसिकली फॉर लॉन्ग रन पीरियड. हाउएवर ट्रांजिएंट स्टेट इज फॉर वेरी स्मॉल पीरियड ऑफ टाइम. On the second figure we have plotted different kinds of this steady state. Various steady states are there, various curves are there, but they are very almost steady. Now the role of exponential distribution. Role of exponential distribution in queuing theory is very important. Here this is basically initiated by this Andre Markov, and that's why this exponential distribution in queuing system is represented by capital M for Markov process, capital M. So suppose that a random variable capital T represents either inter-arrival of customers or service times. This random variable is said to have an exponential distribution with parameter lambda if its probability density function is given by this f of t. F of t, here t is the random variable, t is the time, small t is the time, capital T is the random variable, then this is lambda e raised to the power minus lambda t when t is greater than equal to 0. And when t is less than 0, obviously the value of this function is 0, क्योंकि negative time का तो कोई मतलब नहीं है. So that's why, and if you plot this curve, then generally you are having this exponential distribution. Negative exponential distribution is there because e raised to the power minus lambda t. So that's why negative exponential distribution is there. And in this figure, et basically represents the expected time, expected value of this, which is 1 by lambda. Now here these are some properties of exponential distribution. First is it's strictly decreasing. You have already seen there is a decrease, so obviously it's strictly decreasing. Then, which is another very important property, memorylessness means, what do you think about memorylessness? Depend, which is irrelevant about your past. पिछले दिन क्या हुआ मुझे इससे कोई मतलब ना हो, मुझे सिर्फ आज से मतलब हो, या नेक्स्ट मेरा क्या होगा उसका आज के मेरे डे से कोई मतलब ना हो. So this is very important property of this exponential distribution, memorylessness property. Mathematically this property is represented by here, probability of capital T greater than T plus S when T is greater than S is exactly equal to probability that T is greater than T. यानी कि कैपिटल रैंडम वेरिएबल t ग्रेटर देन s का मतलब वो s टाइम पहले ऑपरेट हो चुका है, उसके बाद वो नेक्स्ट s प्लस t टाइम, यानी कि केवल t टाइम तक ही तो ऑपरेट हुआ ना, s तक तो वो ऑलरेडी हो चुका है, उसके बाद नेक्स्ट t टाइम तक जाएगा, तो लास्ट पॉइंट क्या होगा, t प्लस s। वो जो प्रोबेबिलिटी होगी दैट इज एग्जैक्टली इक्वल टू, अगर आप सिस्टम को स्टार्ट से स्टार्ट करें और सिर्फ t टाइम तक चलाएं, तो उसकी भी प्रोबेबिलिटी सेम ही होगी, दैट इज कॉल्ड द मेमोरीलेसनेस प्रॉपर्टी। Here we have shown this example. Probability of t is greater than 15 minutes when t is already greater than 5 minutes is exactly equal to probability of t is greater than 10 minutes. क्योंकि अगर फर्स्ट लेफ्ट में देखें आप तो 15 माइनस 5 10 ही बैठता है, तो आप या तो स्टार्टिंग से 10 मिनट तक चला लें, या सिस्टम ऑलरेडी 5 मिनट तक चला हुआ है, आप 10 मिनट और चला लो तो 15 मिनट तक खींच लो उसको, तो अल्टीमेटली प्रोबेबिलिटीज जो है सेम आएगी, दैट इज मेमोरीलेसनेस प्रॉपर्टी। हियर थर्ड प्रॉपर्टी इज द मिनिमम एक्सपोनेंशियल्स। If there are number of random variables t1, t2, tm, if you are taking their minimum, then again that minimum is basically again exponentially distributed. This is the minimum property. Fourth one is if Poisson and exponential, they are very much interrelated to each other. So if the time between events, जैसे कि customers आ रहे हैं उनके बीच में जो time है, if that is exponentially distributed, then the number of events, कितने customer आए और उन हर कस्टमर्स के बीच के जो इंटर अराइवल टाइम था, दे आर इंटर रिलेटेड। सो अगर वो जो टाइम है दो कस्टमर्स के बीच का, अगर वो एक्सपोनेंशियली डिस्ट्रीब्यूटेड है, तो जो नंबर ऑफ कस्टमर्स आ रहे हैं वो पॉइसन डिस्ट्रीब्यूटेड होंगे। दैट इज द रिलेशन बिटवीन एक्सपोनेंशियल एंड पॉइसन डिस्ट्रीब्यूटेड। ये फिफ्थ प्रॉपर्टी इज द प्रोपोर्शनैलिटी। प्रोपोर्शनैलिटी मीन्स अगर आपका सिस्टम ऑलरेडी टी टाइम्स चला हुआ है और आप उसको डेल्टा टी टाइम और चलाना चाहते हैं, सो जो प्रोबेबिलिटी है लेफ्ट हैंड साइड जो आपको मिल रहा है, दिस इज एग्जैक्टली प्रोपोर्शनल टू सम स्केलर अल्फा इनटू द टाइम लेंथ डेल्टा टी। द प्रोबेबिलिटी ऑफ एन इवेंट इन द इंटरवल डेल्टा टी इज प्रोपोर्शनल टू द लेंथ ऑफ द इंटरवल। डेल्टा टी इज द लेंथ ऑफ द इंटरवल, इसके प्रोपोर्शनल होगा। आपको पता ही होगा प्रोपोर्शनैलिटी को हमको जस्टिफाई करने के लिए हम जनरली स्केलर से मल्टीप्लाई कर देते हैं, सो दैट स्केलर इज बेसिकली हियर अल्फा। The sixth, aggregation and disaggregation. Left hand portion is basically given to aggregation and the right one is for disaggregation. So here here k number of random variables are there. Each is basically Poisson distributed with parameter lambda 1, lambda 2, lambda k. If you are aggregating, then finally you are having a random variable n which is also Poisson distributed, and here lambda is basically sum of lambda 1, lambda 2, lambda k. On the other side, if you are having this n, right hand side disaggregation, if n is Poisson distributed lambda, then you can disaggregate into say k number of random variables n1, n2, nk, which are also Poisson distributed lambda p1, lambda p2, lambda pk, and here p1, p2, their probability, obviously sum of probabilities is 1, so this is aggregation and disaggregation. Now the cumulative distribution function, that is represented by CDF and mean and variance of exponential distribution. Here first this mathematical expression is basically the CDF, cumulative distribution function of exponential distribution, which is probability of t, capital T is less than small t, is equals to 1 minus e raised to the power minus lambda t. And if you, because here in p is capital T is less than equal to t, अगर आप इसका काउंटर पार्ट लोगे तो क्या होगा, कैपिटल T is greater than t, so p greater than t is greater than equal to 1, क्योंकि टोटल सम जो होता है वो 1 ही होता है, तो 1 माइनस e raised to the power माइनस आप lambda t करेंगे तो अल्टीमेटली e raised to the power माइनस lambda t ही बचेगा, ठीक। Now the mean is 1 by lambda and variance of this distribution is 1 by lambda square. Here we have taken one example. The average time between arrivals is 45 seconds and inter-arrival times are exponentially distributed. What is the probability that two sequential arrivals will be more than 60 seconds apart? Mathematically here arrival is since 45 seconds, so rate is 1 by 45. टाइम जो था वो तो 45 था, उसको जब रेट में कन्वर्ट करेंगे तो 1 by 45 हो जाएगा, so this is the rate. And now probability of random variable t is greater than equal to 60 is equals to e raised to the power minus lambda t. Here the formula is there, this formula. So you apply this formula and you can easily find out. If you plot this e raised to the power minus lambda t, because lambda is 0.0222, So if you plot this against this time t, then you are having this curve. Here this blue portion is basically this 0.2636. The area of this blue portion is 0.2636. Now the Poisson distribution. Next, because Queen theory uses exponential as well as Poisson distribution. So exponential distribution we have already discussed. Now the Poisson distribution. This Poisson distribution is given by the Simon Dennis Poisson, and if the random time between events is exponentially distributed, जैसे मैंने कहा कि अगर आपका जो random events between if the random time between time जो है कस्टमर्स के बीच का आने का, अगर वो आपका एक्सपोनेंशियली डिस्ट्रीब्यूटेड है, तो जो कस्टमर्स के जो नंबर्स हैं वो जो आ रहे हैं, दैट इज पॉइसन डिस्ट्रीब्यूटेड होगा. सो देन इफ द रैंडम टाइम बिटवीन इवेंट्स इज एक्सपोनेंशियली डिस्ट्रीब्यूटेड, देन द रैंडम नंबर ऑफ इवेंट्स in any given period of time follow a Poisson process. And here we have shown this Poisson distribution in this box. The probability of exactly n events within t time and with arrival rate lambda is given by this expression p and t is equals to lambda t raised to the power n e raised to the power minus lambda t divided by factorial, and this is Poisson distribution. Now if you plot this Poisson distribution, so if you use in this this is the formula, p and t is equal to lambda t raised to the power n e raised to the power minus lambda t divided by factorial n. So if you put lambda is equal to 7.5, t is equals to 1, and then if you plot this p and t against by putting n is equals to 0, 1, 2, then you are having this bar chart. Bar chart is there. You can easily, so this is just, you can see almost a normally distributed type of curve. Then these are the notations which are used to model a queuing system. Here first one is small n, number of customers in the system. Small n is basically used to reflect the number of customers in the system. Then nt is the number of customers in the system at time t. T is there. Pn is the steady state probability of n number of customers in the system, and s represent the number of servers, and p and t basically the probability that there are n customers in the system at time t. So here first Pn is basically the steady state, for a steady state, and second P and T is there, time is there, so basically for the transient state is there. Then S is number of servers in the system. Lambda n is mean arrival rate when there are n customers in the system. Mu n is basically their departure rate when there are n customers in the system. Lambda is mean arrival rate when lambda n is constant for all n. अगर अराइवल रेट कांस्टेंट हो कि हर 10 मिनट में एक कस्टमर आएगा तो वो फिक्स है, लेकिन अगर वो ऐसा ना हो तो लैम्डा 1 लैम्डा 2 वो वेरी करे तो लैम्डा n इज देयर. सिमिलरली म्यू इज देयर. डिपार्चर रेट इज, इफ डिपार्चर रेट इज फ्री फ्रॉम n, then this is represented by mu. And utilization factor which is the ratio of coming and their departure, जितने आ रहे हैं और जा रहे हैं जो रेशियो है, that is basically represented by this rho lambda by mu, utilization factor, or this is also known as traffic intensity. तो अगर इसमें ये जो आपकी रो है, अगर ट्रैफिक इंटेंसिटी किसी की ज्यादा है तो वो सिस्टम अच्छा होगा कि खराब होगा? फॉर एग्जांपल रो की वैल्यू 2 है, फॉर एग्जांपल रो की वैल्यू 2 है किसी सिस्टम के लिए, दूसरे सिस्टम के लिए रो की वैल्यू 1 है, तो कौन सा बेटर है? 1 वाला बेटर है, ठीक है ना? क्योंकि जितना ज्यादा ट्रैफिक इंटेंसिटी होगा इतना मतलब उतना कंजेशन रहेगा, या ज्यादा या उल्टा हो गया है? नहीं, मैं कह रहा हूं कि रो की वैल्यू जैसे 2 और मैंने 1 लिया, एक रो 1 लिया एक रो 2 लिया, तो दोनों में सिस्टम बेटर कौन सा है? 1 वाला बेटर है कि 2 वाला है? 1 वाला क्यों?
जैसे उसमें बैलेंस बना रहेगा,
जो आया जो गया. भाई रो की वैल्यू 1 होगी, इसका मतलब क्या होगा? लैम्डा इज इक्वल टू म्यू होगा. आया और गया, सिस्टम बेटर होगा ऑब्वियसली. अगर रो की वैल्यू मैं 2 रखता हूं तो क्या रिलेशन बनेगा? लैम्डा इज इक्वल टू 2 म्यू, लैम्डा इज इक्वल टू 2 म्यू. तो अगर डिपार्चर रेट यानी म्यू की वैल्यू आप 1 रखते हो तो लैम्डा की वैल्यू 2 होगी, तो इसका मतलब कंजेशन ज्यादा होगा, तो रो की वैल्यू जितनी कम रहेगी उतना सिस्टम बेटर रहेगा। क्लियर है? तो these are the inputs actually, number of customers, this the outputs are performance measures. Here ls is expected number of customers in system, lq is expected number of customers in queue, कितने क्यू में लगे हुए हैं सिस्टम में, वो भी काउंट होगा जो सर्विस ले रहा है, और क्यू में सिर्फ वो काउंट होंगे जो सर्विस नहीं ले रहा है। ठीक है ना? हाँ, LW एक्सपेक्टेड नंबर ऑफ कस्टमर्स इन नॉन एम्प्टी क्यू, कितना उसको वेट करना पड़ रहा है एक्चुअली, और WS is expected waiting time in system, and Q represents expected waiting time in queue. Here small q basically for queue and S represent the system. आपको पता लग जाएगा कि L Q का मतलब क्यू के लिए यूज हो रहा है, S का मतलब फॉर सिस्टम के लिए यूज हो रहा है, एंड C बार इज बेसिकली द एक्सपेक्टेड नंबर ऑफ बिजी सर्वर्स, कितने बिजी सर्वर्स हैं किसी सिस्टम में, उसको कैलकुलेट अगर हमें करना हो। नो दीज आर द ब्रीफ आइडिया अबाउट द एक्सपोनेंशियल एंड पॉइसन डिस्ट्रीब्यूशन, जो कि हमने ऑलरेडी डिस्कस कर लिया है, ये उसी के कुछ पैरामीटर्स हैं। तो इफ रेंज इज t greater than equal to for exponential distribution and for Poisson distribution here range is n is equal to 0 1 2, तो इन दोनों से क्या कंक्लूजन निकलता है? रेंज को अगर आप देखें, t is greater than equal to 0, that means a continuous function. However, Poisson n is 0 1 2 discrete. Density function for exponential distribution is given by this, ये हमने already plot भी किया था, and this is the Poisson distribution formula. Mean value is 1 by lambda for exponential distribution and lambda t, ये t represent the arrivals, कितने arrivals आ रहे हैं। Cumulative, ये हमने already इसका formula लिखा था। Similarly इसका cumulative क्या होगा? discrete है क्योंकि आप सबका sum कर सकते हो। p number of arrivals during period time t, this is, ये भी हम लोगों ने ऑलरेडी देखा था जब हमने डिस्कस किया एक्सपोनेंशियल। सिमिलरली यहाँ कोई अराइवल ही ना हो तो n की वैल्यू 0 रहेगी, पॉइसन डिस्ट्रीब्यूशन के फॉर्मूले में n इक्वल टू 0 रख लो तो p नॉट निकल जाएगा। सो दिस इज, दीज आर द सम फॉर्मूले। नाउ दिस इज बेसिकली द मैथमेटिकल, क्योंकि कोई भी सिस्टम आप बनाते हैं मैथमेटिक्स में तो कुछ इनपुट होगा कुछ आउटपुट होगा। सो इनपुट्स आर बेसिकली द फेलियर रेट से लैम्डा, म्यू और n नंबर ऑफ कस्टमर्स। क्विंग मॉडल आप डेवलप करेंगे, कुछ उसको सॉल्व करेंगे तो कुछ परफॉर्मेंस मेजर्स आएंगे। दीज आर LS व्हिच वी हैव ऑलरेडी briefly discussed, LQ waiting time in queue, waiting time in system, then traffic intensity rho and the probability Pn. So these are the outputs and these are the inputs. Now here we are having an output. तो ये जो हमारे परफॉर्मेंस मेजर्स हैं इनके बीच में भी कुछ आपस में रिलेशंस होते हैं। These relations are basically modeled, so these are known as Little's formula. These are the 4 very important formulae developed by J. Little. So LS is equals to lambda WS, LQ is equals to lambda WQ, WS is equal to WQ plus 1 by mu, and LS is equals to LQ plus lambda by mu. So these are the 4 formulae known as Little's formulae, and now we will discuss briefly these 4 formulae, their explanation actually. Here, in steady state, a newly arriving customer expect to see a queue of length q. जब आप किसी सिस्टम में एंटर होते तो आप कुछ एक्सपेक्ट तो करते ही हो कि भाई एक दो कस्टमर खड़ा हुआ होगा, लाइन में लगा हुआ होगा। सो दैट इज बेसिकली LQ, लाइन ऑफ द लेंथ। अब सिस्टम वो आ गया है, अब उसको कुछ वेट करना पड़ेगा, so that is represented by WQ. So customer is expected to be in queue for WQ time. वो आया, उसने देखा लाइन लगी हुई है, उसको थोड़ा वेट करना पड़ा, that wait is basically WQ. अब क्या होगा? अब जब वो लाइन में लगा हुआ है तो ऐसा तो नहीं कि जब वो लाइन में लग गया तो और कोई पीछे नहीं आएगा, कस्टमर तो आ ही रहे हैं ना। सो ड्यूरिंग दीज WQ टाइम्स, जितना वो वेट कर रहा है उसकी क्यू लेंथ भी तो पीछे बढ़ रही है। तो टाइम यूनिट्स, वन एक्सपेक्ट दैट लैम्डा WQ न्यू कस्टमर्स अराइव, उस ड्यूरेशन में जो कस्टमर्स आएंगे दैट इज बेसिकली लैम्डा WQ। अब सो द क्यू लेंथ इज एक्सपेक्टेड टू बी लैम्डा WQ। जब वो डिपार्ट करेगा तो कम से कम वो जो वो एक्सपेक्ट कर रहा था कि जो उसके पीछे खड़े हैं, तब वो क्यू को फॉर्मुलेट कर लेंगे। जब वो चला जाएगा तो तब वो कस्टमर जो आ रहे हैं तब उनकी क्यू बन जाएगी. So the queue length is expected to be lambda wq when the customer leaves the queue. So ultimately क्या हुआ, जो उसने स्टार्ट में देखा था कि लैम्डा एल क्यू है, जब वो एंटर किया था क्यू बनी हुई थी, और जब वो चला गया डब्ल्यू की, दोनों बराबर हैं क्योंकि सिस्टम तो हमारा स्टेडी स्टेट में है. So that's why LQ is equals to lambda WQ. This is the relation. Clear है ना? So this is the explanation of one formula. Similarly, you can formulate another formulas. Now the birth and death process. जो कस्टमर आ रहा है किसी सिस्टम में, that is called the birth process. और जब वो जा रहा है, that is called the death process. So here a simple queuing system is a special case of birth and death process. Birth means arrival of customers. Death means departure of customers. State NT is the size of population at time T. Birth and death happens randomly with rates possibly depending on the size of the population. जो पॉपुलेशन की साइज है उसी के हिसाब से तो अराइवल और डिपार्चर डिसाइड भी होंगे, उसी हिसाब से हमारी सर्विस फैसिलिटी भी डिसाइड होगी. सो नाउ द assumptions, क्योंकि जब हम कुछ मॉडलिंग करते हैं तो उसके लिए कुछ assumptions भी हम लेते हैं. सो दीज आर द assumptions. Given time t and state nt is equals to n greater than equal to 0, the probability distribution of the remaining time until the next death is exponential with parameter mu n. Here lambda basically represents the arrival rate and free from time, and mu n represents the departure. The random variable of the above assumptions are mutually independent. Mutually independent means they are not dependent on each other. The process is in steady state. Steady state means time के ऊपर उसकी कोई dependency नहीं, steady state है. Now the balance equation, which is very important. Balance equation means जो इनफ्लो हो रहा है सिस्टम में और जो आउटफ्लो हो रहा है, वो दोनों जब इक्वेट करते हैं तो इक्विलिब्रियम बनता है. दैट इज वो जो इक्विलिब्रियम किसी इक्वेशन के थ्रू बनता है, इनफ्लो और आउटफ्लो, दैट इक्वेशन इज कॉल्ड बैलेंस इक्वेशन. सो हियर एट एनी टाइम द नेक्स्ट स्टेट ट्रांजिशन इज आइदर फ्रॉम n to n+1 और फ्रॉम n to n-1. फॉर एग्जाम्पल अगर इनिशियली 10 कस्टमर थे सिस्टम में, आपने एंटर किया, तब कस्टमर कितना हो गए टोटल 11, n+1. जब आप वहां से, दूसरा केस था जब आप सिस्टम में थे तब टोटल आप 10 थे, जब आप वहां से निकले एक कम हो गया तब 9 ही बचे, तो आप n-1 स्टेट में चले गए. ठीक, तो 3 स्टेट्स हो गई, n, n-1 और n+1. सो डिफाइन en and ln to be the rate, average number of events per unit time at which the system enters. E represents enters and L represents leaves, जब आप सिस्टम को छोड़ते हैं रेस्पेक्टिवली. और बैलेंस इक्वेशन क्या बनेगी, जब एंटर और लीविंग दोनों सेम हो, इक्विलिब्रियम बने. सो En is equals to Ln, that means rate in is equals to rate out. This is called the balance equation. और यही हम जब फॉर्मुलेशन करेंगे डिफरेंट मॉडल्स का, यही बैलेंस इक्वेशन काम करेगी उसको मॉडलिंग करने में. नाउ दिस इन एंड आउट जो भी मैंने यहाँ बनाया n और n+1 और n-1, इसी को अगर हम किसी ट्रांजिशन डायग्राम के थ्रू शो करें तो दिस इज ट्रांजिशन डायग्राम. कोई भी मॉडल आप बनाएंगे तो ट्रांजिशन डायग्राम की जरूरत पड़ती है उसको रिप्रेजेंट करने के लिए मॉडल को. सो हियर इन सर्किल में आप देखेंगे 0, 1, 2, n-1, n, n+1. हियर फॉर एग्जांपल इन दिस सर्किल n इज देयर, n मींस n नंबर ऑफ कस्टमर्स वहां पे अवेलेबल थे. ठीक, इसके बाद एक कस्टमर और आया, क्योंकि n ऑलरेडी सिस्टम में थे. सपोज जो कस्टमर आया, क्योंकि वो जो आ रहा है वो ये देख के आएगा कि लेंथ कितनी बनी हुई है, उसी हिसाब से तो एंटर करेगा. यानी कि उसका अराइवल रेट डिपेंड करेगा जो ऑलरेडी सिस्टम में जितने कस्टमर्स हैं n के ऊपर डिपेंड करेगा. दैट्स वाई जब वो एंटर करेगा तो अराइवल रेट इज लैम्डा n, और जब वो एंटर कर जाएगा तो नंबर ऑफ कस्टमर कितने हो गए, n+1, तो नेक्स्ट वाली सर्किल में वो चला गया. इसी तरह अभी वो n में ही है मान लो, और वो डिपार्ट करता है तो n-1 हो जाएंगे, तो तब वो इससे पहले वाले सर्किल में पहुंच जाएगा स्टेट में, और उसका डिपार्चर रेट म्यू n रहेगा, क्योंकि जब वो डिपार्ट कर रहा था तब उस समय तो सिस्टम में n नंबर ऑफ कस्टमर्स ही थे, तो दैट्स व्हाई म्यू n इज देयर. सिमिलरली जब वो n+1 में चला गया, ऐसे ही तब कोई एक कस्टमर निकलता है तो वो n स्टेट में आ जाएगा. सो दिस इज द ट्रांजिशन डायग्राम. आई थिंक दिस इज क्लियर. So this is the transition diagram. Now steady state probabilities. I think ये हो चुका है. We have already discussed about the steady state probabilities. Now steady state analysis of birth and death process. So here, this is the diagram which we have already discussed. So birth death process means, मान लिया कि हमारा सिस्टम nth स्टेट में है, n नंबर ऑफ कस्टमर्स आर ऑलरेडी देयर, एक डिपार्ट करता है या आता है कोई कस्टमर, सो दैट इज रिप्रेजेंटेड बाय, तब वो या तो n+1 स्टेट में चला जाएगा या वो n-1 स्टेट में चला जाएगा. So here we have established our transition diagram is this. Now based on this we have developed the balance equation. यहाँ अब अगर आप सबसे पहले हम करेंगे कि n इवेंट से जब हमारा कस्टमर हमारा सिस्टम n स्टेट से n+1 स्टेट में जा रहा है, तब अराइवल रेट लैम्डा n था और उसी के साथ उसकी प्रोबेबिलिटी क्या रही होगी, Pn रही होगी अकॉर्डिंग टू द पॉइसन डिस्ट्रीब्यूशन. सो हियर वी हैव टेकन दिस. पहले n-1 वाला डिस्कस करते हैं ताकि इन और आउट. इन फर्स्ट एक्सपेक्टेड रेट ऑफ फ्लो इनटू स्टेट n. स्टेट n में जाने के क्या क्या तरीके हैं. यहां से एक तरीका यह है कि n-1 कस्टमर रहे हो, एक कस्टमर और ऐड हो जाए तो n स्टेट में आ जाएगा. ठीक है ना. तो उस समय प्रोबेबिलिटी क्या रही होगी अराइवल की, लैम्डा n-1. Pn-1 से मल्टीप्लाई करो तो वो n स्टेट में आ जाएगा. ऐसे ही दूसरा चांस क्या रहा होगा कि जब n+1 कस्टमर रहे हो और एक डिपार्ट कर जाए तब भी वो n में आ जाएगा. दोनों का सम कर लो, एक्सपेक्टेशन निकल जाएगी. सो हियर इज फर्स्ट इक्वेशन इज बेसिकली एक्सपेक्टेड रेट ऑफ फ्लो इनटू स्टेट n. जब वो n-1 से n में गया तो प्रोबेबिलिटी थी, रेट था लैम्डा n-1 मल्टीप्लाई बाय Pn-1 प्लस सेकेंड ऑप्शन इज जब वो n+1 से डिपार्ट किया तो रेट रहा होगा μn+1 मल्टीप्लाई बाय प्रोबेबिलिटी इज Pn+1. इसी तरह nth स्टेट से बाहर जाने के क्या क्या ऑप्शंस हैं. एक ये कि एक कस्टमर और आ जाए तो वो n+1 स्टेट में चला जाएगा. उस समय क्या प्रोबेबिलिटी रहेगी, लैम्डा n इज द अराइवल रेट मल्टीप्लाई बाय Pn. दूसरा ऑप्शन क्या है, वो n से n-1 में चला जाए, n में से एक कस्टमर और निकल जाए तो n-1 में चला जाएगा, तब डिपार्चर रेट इज μn मल्टीप्लाई बाय Pn. हियर अगेन प्रोबेबिलिटी इज Pn. जब अराइवल हुआ n से n+1 में गया तब भी प्रोबेबिलिटी Pn थी, और जब डिपार्चर हुआ n से n-1 की तरफ तब भी प्रोबेबिलिटी Pn ही थी. सो कॉमन फैक्टर इज Pn. When you are taking their sum, that's why there is lambda n plus μn multiplied by Pn. And now system is in equilibrium state, so inflow is equal to outflow. You can equate these two equations. This is basically the balance equation. And here n is 1, 2, 3, 4 because n-1 is there. So you cannot take n0. Otherwise lambda -1 नहीं हो सकता. लैम्डा नॉट हो सकता है, कोई सिस्टम में ना हो. ऐसा नहीं हो सकता कि -1 कस्टमर इज देयर, इसके कोई चांस नहीं है. And now since this is a probabilistic concept, so take the sum of all the probabilities from I is equal to 0 to infinite, then their sum is 1. इसी को जब n की वैल्यू मैंने 0 रखी तो फर्स्ट इक्वेशन इज देयर, μ1 p1 इज इक्वल टू लैम्डा नॉट p नॉट. उस इक्वेशन में डायग्राम से भी आप देख सकते हो, ये जब आप 0 स्टेट में हैं, एक अराइवल हुआ लैम्डा नॉट इज देयर, एक अराइवल हुआ 0 स्टेट से और प्रोबेबिलिटी क्या रही होगी p नॉट मल्टीप्लाई देयर लैम्डा नॉट p नॉट. इसी तरह 1 स्टेट से जब आप 0 स्टेट में जाएंगे तो हियर 1 स्टेट में जब आप थे तो डिपार्चर हुआ μ1 एंड प्रोबेबिलिटी इज p1 क्योंकि आप 1 स्टेट में थे. दोनों को इक्वेट करेंगे. सो फर्स्ट आप डायग्राम से चले जाएं चाहे बैलेंस इक्वेशन का यूज करते हुए चले जाएं. यू आर हैविंग फर्स्ट इक्वेशन μ1 p1 इज इक्वल टू लैम्डा नॉट p नॉट. यहां से आप p1 इक्वेलुएट कर सकते हैं. p1 इज इक्वल्स टू लैम्डा नॉट μ1 डिवाइड बाय μ1 इनटू p नॉट. नाउ फॉर सेकंड, जब आप n इज इक्वल टू 1 रखेंगे तो 1 में भी आप 0 से आ सकते हो और 2 से आ सकते हो. इसी तरह जब बैलेंस इक्वेशन बनाएंगे तो इक्वेशन बनेगी, यहां से आप p2 निकाल लीजिए तो p2 जो आएगा वो आएगा लैम्डा 1 डिवाइडेड बाय μ2 इनटू p1. अब इक्वेशन नंबर 1 से आप p1 को यहां रिप्लेस कर सकते हो तो P2 यू कैन कैलकुलेट इन टर्म्स ऑफ P नॉट, निकाल सकते हैं इजीली। इसी तरह आप जब nth इक्वेशन की बात करेंगे, nth स्टेट की, सो यू आर हैविंग दिस बैलेंस इक्वेशन, जो कि हमारी ओरिजिनल जो हमने nth के लिए ही बनाई थी वही इक्वेशन है। यहां से आप Pn इवेलुएट कर सकते हैं, दिस इज इक्वल टू दिस रिलेशन, एंड Pn माइनस वन जैसा कि हमने 2 के केस में किया, P नॉट की फॉर्म में लिख सकते हैं। ऐसे ही Pn को भी, जब Pn माइनस वन को भी आप P नॉट की फॉर्म में लिखेंगे, तो अल्टीमेटली in the second box you can have Pn in terms of lambda n minus 1 lambda n minus 2 into this mu n minus 1 mu 1 is equal to P नॉट। आप रख के देख लो, n की वैल्यू 1, आपकी P1 निकल जाएगा, n is equal to 2 रखेंगे तो प्रोडक्ट्स की फॉर्म में आपका P2 निकल जाएगा। तो वही इक्वेशन है। क्लियर है सबको? और जब आप इन सब प्रोबेबिलिटीज का सम करेंगे, अल्टीमेटली देयर सम इज इक्वल टू 1, दिस क्वांटिटी। ठीक, जब आप इनका सम करेंगे तो कैसी इक्वेशन बनेगी? इस समेशन फॉर्म में जो लिखा हुआ है, ये P नॉट प्लस P1 इज इक्वल टू P2 प्लस P3 Pn इज इक्वल टू 1। अब P1 को भी आप P नॉट की फॉर्म में, you can also write down P2 in terms of P naught, you can also write down P3 in terms of P naught, so ultimately you can write down all the Pn's in terms of P naught, so you can take P naught common and then divide by जो आएगा ब्रैकेट में, and right hand side में 1 रहेगा, 1 divided by that quantity, so that quantity is represented here 1 by summation of Ci's, and here Ci's are nothing but this lambda, this factor, and so you, and since Pn can be represented in terms of P naught, so that factor multiply by P. So this is the relation. Now this is the performance measure, expected number of customers in system and in QE, this is LS is equals to summation of एक्सपेक्टेड निकालना है। तो एक्सपेक्टेशन तो आप लोगों को प्रोबेबिलिटी में पढ़ा होगा, जब निकालते थे तो नंबर ऑफ n से मल्टीप्लाई किया, मल्टीप्लाई बाय द Pn, तो एक्सपेक्टेशन निकल जाती थी। सो यही है LS, सिस्टम में n कस्टमर्स हैं, सो n इज देयर and at that time probability is Pn. When you multiply nPn and take the sum, then this will provide you the expected number of customers in the system. Similarly जब QE है और फॉर एग्जांपल S नंबर ऑफ, या मैंने C लिखा है, तो C नंबर ऑफ कस्टमर्स सर्वर्स अगर वहां पर हैं, फॉर एग्जाम्पल 10 नंबर ऑफ कस्टमर्स हैं सिस्टम में और 2 सर्वर लगे हुए हैं, तो इसका मतलब 10 में से 2 तो वहां एंगेज होंगे जो अपनी सर्विस ले रहे होंगे, बाकी 8 जो है वो विट क्यू में होंगे। सो दैट्स व्हाई n माइनस सी इज देयर, मल्टीप्लाई बाय प्रोबेबिलिटी Pn, and when you take the sum, because n starts from C, क्योंकि क्यू तो कहां से बननी स्टार्ट करेगी? C प्लस 1 से, C से स्टार्ट होगी ना, तो C, and it starts from C to infinite, then you will have the expected number of this customers in the queue. क्लियर है ना दोनों फॉर्मूले? Now the Kendall notations. Kendall notation is basically, बस 2 मिनट और इसके बाद फिर हम मॉडलिंग करेंगे। Kendall notation क्या इसके बाद ही करना है बताओ? हाँ चलिए क्वेरीज लेंगे। जी JSS Academy Noida. Is there any query?
Hello.
Yes.
No query.
Yes.
No query, sir. Thank you.
No query. Okay. Thank you. Then JIET Jodhpur. Is there any query? Is there any query? Yes.
Hello.
Yes. Is there any query from Jodhpur?
Hello. Hello.
Yes. Yes. Is there any query?
Hello.
आपको कोई क्वेरी है तो आप पूछ सकते हैं from जोधपुर। next ले. PVP Siddharth, Institute and Technology. Is there any query from Vijayawada?
No, sir.
No, sir. Thank you. Is there any query? Jaipur, no? Jaipur Engineering College. Is there any query?
No, sir. No query, sir. Sir, is there any easy way to memorize this all these formula?
Can you repeat again?
Sir, I'm asking, is there any easy way to memorize all these formula or any tricks?
Actually, you have to spend some time. You can calculate. You can, if you are giving some time to this model process queuing theory, then obviously you can understand all these formulae very immediately. No problem. You just pay some time.
Okay, sir. Thank you.
Any other? हैं? उदयपुर Vidya Bhavan Polytechnic College, Udaipur. Is there any query? No. हो गया? नो क्वेरी तो तभी है या तो हमने अच्छा पढ़ा है या उनको समझ में नहीं है. Okay. So now we are taking a tea break for 15 minutes and then we will come back again. Thank you.
Hello. Hello.
Is there any query?
Yes, sir.
Yes. Yes.
Just a second, sir. We have a query, sir.
Yes, from Jodhpur. Yes, sir.
Of course, the lecture and the contents provided by you are wonderful, no doubt of it. But for the beginners and for the learners, I think the things are projected in a very difficult manner. Because of course, the thing condition equation that is being given by you people
Yes.
is definitely narrated in a very nice manner in Papa's book. And because you are the master of the subject and know more of the things very nicely,
Yes.
so explanation can be carried out of the transition equation through Papa, and the clarity will be rather more. Secondly, in twin theory, fundamentally, in all the books which we have gone through, it has been given that lambda should be always equal to greater than mu. Without that, the Q process cannot be progressed.
Yes.
So fundamental assumptions has not been given.
Yes.
Not many assumptions are there before making out, because we have taken the base of the Poisson distribution and the Adlam distribution and exponential distribution only. But basic assumptions beyond this which have not been discussed in the lecture. So if that would have been discussed, I think it would have been more clear. Thank you, sir.
Okay. Fine. Okay. Thank you. क्वेरी नहीं थी एक्चुअली वो जो जो पूरा यूनिवर्सिटी में उसको वो ओवरव्यू करना है कि हाँ वो कह रहे कोई इजीली बताने वाले कभी ज्यादा नहीं है मेरे टाउन ऐसे बोलते
तो ये काफी इनको दे सकते हैं, ये काफी इनको दे सकते हैं।
ये प्रॉब्लम हो। हाँ, मास्टर कम कर देंगे तो वो आवाज आनी बंद हो जाएगी उधर से। तो ये ऑक्सिलरी वाला ये क्या है, 4 नंबर? सुनो ना, म्यूजिक का थोड़ी है। हाँ, म्यूजिक का है। म्यूजिक तो आ ही नहीं रहा उधर से, तो आवाज आती है। हैं? नहीं, म्यूजिक तो उधर से भी चलाते नहीं है वो। आवाज अलग बंदा ना, आवाज धीरे बंदा। ऐसे करके। बाद में मैंने सेट कर दिया था, कंपनी के बाद में मैंने सेट किया था।
फिर इसका डिपार्टमेंटल हो चुकी है और अभी प्री थीसिस होगी मेरे।
अच्छा अच्छा।
हाँ, फिर थीसिस होगी नवंबर में।
तो यहाँ के अभी जैसे कोर्स आप
यस ये तो ऐसे कोर्स ज्यादा कंसर्न नहीं था ना सर, मेरा तो इलेक्ट्रॉनिक्स की
वो सेकेंडरी वर्ष से मॉर्निंग ओरिजिनल इसको आया नहीं पड़ेगा
किस कौन है? हाँ
ये
सर।
जरी से खींची थी फोटो और सेंड कर दे।
हाँ एक ब्रेक खत्म हो गया सर, एक टी ब्रेक भी कर लिया। हाँ 11:30 बजे से स्टार्ट करेंगे दूसरा सेशन।
वो जरी ने की चेंज है नो लाइन के ले जो दिखाया से
बताओ।
वो ना
अच्छा
सही मेरे वो ना प्रिंटर कॉल पे आओ ना काफे ले आगे सारा उसके सारे की
कहाँ पे आना है?
हैं जरी का
अच्छा अच्छा अच्छा
वो ले आगे
2:30 बजे। हाँ ठीक है ठीक है।
क्या जी
2:30 बजे रहेगा यहीं पे।
फोटो सेंड करके वो ले जाती है ले काफे लगे तो लाइन के दिखाया
क्या स्टार्ट करें क्या?
ਉਹਦੇ ਹਿਸਾਬ ਨਾਲ ਹੈ ਪ੍ਰਿੰਟਿੰਗ ਦੇ ਹਿਸਾਬ ਤੋਂ प्रोडक्ट ਦੇ ਹਿਸਾਬ ਨਾਲ
जल्दी खत्म।
रॉ मटेरियल ਦੇ ਹਿਸਾਬ ਨਾਲ ਕਿਹੜੇ ਵਾਲੇ ਚਾਹੀਦੇ
आईसीटी वाला कनेक्शन है ना, उसमें वाला नहीं निकल पाएगा। आईसीटी वाला
सर वो भी ऐसे ही है, वो बल्कि हम यहाँ बैठे हुए
नहीं, आप लोगों को तो फिर भी कुछ ज्यादा समझता होगा।
हाँ
ये फेस टू फेस रहता है ना।
फेस टू फेस भी रहता है वहाँ पे, फिर वैसे ही आलसी हो जाते हैं बैठे बैठे बैठे। और जो डिपार्टमेंट से कंसर्न नहीं है, ऐसे 32 की स्ट्रेंथ शो करे कि 32 मैथमेटिक्स डिपार्टमेंट से थोड़ी ना है स्टाफ, वो दूसरे डिपार्टमेंट के बैठे हैं, तो वहाँ तो स्लाइड्स जा रही हैं, आपकी आवाज जा रही है।
आईसीटी इतना
विजिबल नहीं है।
उससे बेटर ये जो एनपीटीईएल के थ्रू लेक्चर यूट्यूब पे डालना ज्यादा बेटर है।
अरे वो लिमिट वाले लोगों भी कर जाके ना टीचर उन लोगों को क्लिक करके साइन कर हाँ क्लिक करके फिर एनपीटीईएल की जैसे हमारा भी वेब पोर्टल है एनसीटीईएल, ये आपके लेक्चर सभी उधर ही जाएंगे।
अच्छा
हाँ जी।
तो उसमें क्या बस ये जो रिकॉर्डिंग हो रहा है ये अपलोड कर देंगे आप?
हाँ जी
तो वहां से हम भी डाउनलोड कर सकते हैं?
बिल्कुल सर। ऐसा सर नीटर है जो ये आईसीटी नीटर करवा रहा है, ये सबसे इजी वे एंड सबसे इकोनॉमिक वे में करवाओ। बाकी तो सर वो तो टीचर्स पे डिपेंड है कि आप कैसे ले रहे हो। उधर तो आपकी ऑडियो
वही बात में कह रहा हूं,
जितने क्वेश्चंस जैसे वहां से आ रहे यहाँ से भी मेरे ख्याल से उतने ही आते हैं, यहाँ से भी ऐसी आ जाता है नौकरी। अब वो तो टीचर क्या कितना स्टूडेंट पे कितना ले रहे हो आप,
उनकी क्वालिटी अच्छी रहती है, हो सकता है उसको वही कॉस्ट ज्यादा लगता होगा। नहीं उनके यहाँ भी कम से कम चलो यहाँ पे ये है ना, इसमें उसमें एक फर्क ये है ना, इसमें ऑनलाइन पार्टिसिपेंट नहीं, उसमें ऑनलाइन नहीं होता।
हाँ जी इसमें
उसमें तो स्टूडियो में बिठाया आपने, नहीं बिठाया तो भी कोई प्रॉब्लम नहीं, आपकी रिकॉर्डिंग हो रही है। उसमें क्या है, इसमें ऑनलाइन ही बैठे हैं, आप भी बैठे हो, इंटरेक्शन थोड़ा है।
वैसे कोई कोर्सेज होते हैं कि काफी इंटरेक्टिव भी होते हैं, जैसे कम्युनिकेशन स्किल्स वगैरह, वो वो तो ऑनलाइन डिबेट वगैरह की बात है, ग्रुप डिस्कशन।
नहीं इसमें तो फिर कमेंट टॉपिक कैसे हो गए ना।
अब इसमें तो इतना इतना पूछ सकते हो।
हाँ बिल्कुल। ये 5 मिनट बात करें इसका
फिर थोड़ा सा
ऐसा कुछ टाइम बाउंडेशन नहीं है
नहीं सर।
नहीं सर,
तो अभी शुरू करेंगे अभी
अभी कर देते हैं।
चलो करते हैं, ये फ्री हो जाएंगे और क्या। So welcome again all the participants. In the continuation of my previous lecture, now we will study about this Kendall notations. Kendall notation is basically used to represent different kinds of models. Here 5 quantities are used. In some books you can find out 6 quantities, but most commonly 5 or 4 or even 3 quantities are used to represent the different kind of queuing models. These quantities are A, B, C, D and E. First bracket we are having 3 quantities A, B and C. In second bracket we are having 2 quantities D and E. So here A represents probability distribution of inter-arrival time of customers. B represents probability distribution of service times. C represents number of servers. D represents capacity of the system, the maximum number of customers in the system, including the one being served. And E represents the queue discipline, which we have shown first come first serve, last come first serve, likewise. So these are the disciplines. So now here A means since arrival process, so here we can have either Markovian process, deterministic, Erlang and general. For sake of time we have used only the Markovian process, exponential distribution Poisson process, so M is used. Similarly B means service process, this square. Here we are having service process, M for Markovian, again same representation, D for deterministic. That means A may have either M, D, ER or G. Similarly B may have either M, D, ER or G value as far as value is concerned. C means number of servers, C equal to 1, 2, 3. Similarly D means system capacity. System capacity may be 1, maybe 2, maybe 3 or infinite. And last E is service discipline. First come first serve, last come first serve, 0, GD and so on. So these are the values actually. Now if we are talking about of models which we will use in this lecture, we have developed 4 models. First model is M is Markovian arrival. First model MM1 infinite and FCFS. First M means Poisson arrival. Second M means service time pattern is Poisson, exponential distributed. And 1 means there is only one server. Infinite means infinite capacity is there. Then first come first serve. First come first serve is the discipline. Similarly second model MMS, so 1 is replaced by S here. Then we are having second model. Here Poisson arrival, exponential distribution for service time. Then S number of servers are there, infinite capacity is there, and first come first serve is the discipline. Now in third model, S is replaced by 1 and infinite is replaced by N. Then we are having third model. Here Poisson arrival, exponential distributed system, this service time. One server is there, N number is the capacity of the system, and first come first serve is the discipline. Last MMS and FCFS, that means Poisson arrival, exponential distribution for service, S number of servers are there, N is the capacity, and first come first serve is the discipline. So these are the 4 models which we will develop. Now first model MM1 infinite FCFS. First model. Functions. Arrivals are served on first come first serve basis. No barking and reneging. Arrivals are independent of each other, but rate is constant. Here arrival rate is constant. That means which we have used in transition diagram lambda n. So here lambda n is basically simply lambda. Does not depend upon number of customers in the system, free from n. Similarly, arrival follow a Poisson distribution. Single server and infinite capacity is there. Service time are variable and independent, but the average is known. Service time follow an exponential distribution, since we have represented by m, Marconian, and average service rate is greater than the average arrival rate. Why? Service rate is greater than average arrival rate. इसका मतलब in terms of lambda and mu, mu is greater, lambda is smaller. यही तो हुआ ना, यही तो हुआ ना. लैम्डा आपका छोटा है, म्यू आपका बड़ा है. इसका मतलब लैम्डा बाय म्यू का रेशियो कितना होगा? ग्रेटर देन 1 होगा, लेस देन 1 होगा? जब म्यू बड़ा है तो ऑब्वियसली लेस देन 1 होगा. लैम्डा इज लेस देन म्यू. इसका मतलब आप सर्विस में ज्यादा टाइम लगा रहे हो और अराइवल आपके कम है, तभी तो आपकी क्वालिटी अच्छी आएगी. अगर आपके अराइवल्स ज्यादा हो जाएंगे और सर्विस में आप कम टाइम लोगे तो क्या होगा? कंजेशन ज्यादा हो जाएगा, भीड़ बढ़ती चली जाएगी, एक्सप्लोसिव स्टेट आ जाएगी, सिस्टम कोलैप्स कर जाएगा. ठीक है ना? तो दैट्स व्हाई दिस अजम्पशन इज एसेंशियल कि आपका एवरेज सर्विस रेट इज ग्रेटर देन द अराइवल रेट. उल्टा लेंगे तो कोलैप्स हो जाएगा सिस्टम. Now here, this is the method, the geometrical the representation of the system. Here lambda is the Poisson arrival, and t is the state number of customers in the system at time t, and mu is the exponential distributed service time. Now here, in terms of transition diagram, since we have already taken in the assumptions, arrivals are independent of each other, but rate is constant over time. Similarly, that means lambda n is basically lambda. Similarly, mu n is equals to mu. So that's lambda n is equals to n lambda and mu n is equals to mu. And since last assumption is lambda is less than mu, so that's why utilization factor or traffic intensity is less than 1, so that our system is stable. That's why. Now this is the transition diagram. Here lambda n's are replaced by simply lambda, constant lambda, and mu n's are replaced by mu. So same transition diagram is here, and this Pn we have already developed this formula earlier, so this formula is there. Now using this formula, now transition diagram is there, you can use to find out the balance equation for state 0, for state 1, for state 2, and so on. So similarly here, this P1 is equal to rho P1 is nothing but your first equation. Rho is nothing but lambda by mu. Lambda by mu is replaced by rho. So first equation is there. Similarly P2. P2 is, use put P2, n is equal to 2. So you are having lambda 1 into lambda naught divided by mu2 equal into mu1. But since lambda 1 or lambda naught, they are nothing but simply lambda, so that's why lambda by mu whole square, and since lambda by mu is nothing but rho, so that's why square p naught. Similarly Pn is equals to rho n multiply by p naught. From this simply just lambda n minus 1 equal to lambda n minus 2 is equals to lambda. That's why you are having this relation. Now since the sum of all the probabilities is 1, so that's why this relation is there. Substitute all these values. So here, since Pn is raised to the power n p naught, so substitute here. Now p naught is free from n, so you can take common. So p naught, and now divide the summation. So here 1 by summation of this rho raised to the power n, and since this is a geometric series, and geometric series all, so you can take the sum, and since this is the infinite sum, and rho is less than 1 we have already taken. So for if you are taking the sum of a geometric series, infinite sum, then its value is 1 by a by a minus rho. Here a is 1, put n is equal to 0, so first value is 1, so that's why sum is 1 by 1 minus rho. Simplify this, this is 1 minus rho. So P naught, that means there is no customer at time 0, at initially its probability is 1 minus rho. And now substitute this value in this equation here, so you are having this relation rho n multiply by P naught. P naught is 1 minus rho, so this is the relation Pn in terms of rho. Put n is equal to 0, 1, 2, 3 and you can find out all the probabilities. Here next performance measure is expected number of customers in the system. So here LS is expected number of customers. So suppose at time t there are n number of customers, probability is Pn, so this is the expectation n L Pn. N Pn is this rho raised to the power n 1 minus rho, so substitute here, so you are having this relation. Now you can take 1 minus rho into rho common, then you are having this summation. Now you can see n rho raised to the power n minus 1. अगर आप इसको डेरिवेटिव की फॉर्म में लिख दें तो क्या हो जाएगा, d by d rho raised to the power n. इसको डिफरेंशिएट करेंगे तो ये, और डेरिवेटिव का अगर आप समेशन से बाहर रखें, so then you are having this relation 1 minus rho d by d rho summation of rho raised to the power n. अगर आप term by term differentiate करेंगे तो again you are having same expression term by term. Now rho raised to the power n is there, summation is from n to 0, again infinite series is there, take the sum which is 1 by 1 minus rho. Now differentiate this, so you are having rho by 1 minus rho square into 1 minus rho. Now ultimately you are having rho by 1 minus rho. Now replace rho by lambda by mu, then ultimately you are having this relation lambda by mu minus, so expected number of customers in the system is lambda by mu minus lambda. So this is the next performance measure is LQ, which is expected number of customers in the queue. So since there is single server, MM1 is there, that means server is 1. So अगर n number of customer किसी टाइम पे होंगे, n customers हैं सिस्टम में, एक सर्वर है तो क्यू में कितने लगे हुए होंगे, n minus 1. So that's why LQ is summation n minus 1 into Pn, n minus 1 customers in queue. So now again apply same approach, you can take the summation, bifurcate this n minus 1 into two parts, n Pn minus 1 Pn. So now this is the two summations are there, so summation n Pn minus summation P naught. Since here in the second summation n starts from 1, so if you are adding one term P naught and at the same time you are subtracting P naught, so you are having this summation. Now LS minus first summation is nothing but your LS, which you have already calculated previous, so this is LS, and second summation is basically summation from all the probabilities, and we know that summation of all the probabilities is nothing but 1, so LS minus 1 plus P naught. And now LS in terms of lambda and mu is this minus 1 plus P naught is, we have already computed it, minus rho. So just substitute there 1 minus rho. So ultimately you are having LQ is equal to lambda square divided by mu into mu minus lambda. तो अगर आपके पास mu है, lambda है, तो आप expected waiting जो आपका क्यू में लग रहा है वो आप निकाल सकते हो. Now here solving for WS, waiting time for the system and waiting time in queue. So WS and WQ. So using Little's formula, WS is nothing but LS by lambda. जो चार फॉर्मूले मैंने स्टार्ट में बताए थे उन्हीं में से ये WS is equal to LS by lambda. So here substitute all these values, so ultimately WS is 1 by mu minus lambda. Similarly WQ is WS minus 1 by mu. So substitute WS 1 by mu minus lambda minus 1 by mu, simplify this, so lambda by mu into mu minus lambda, this is WQ. Because rho is nothing but lambda by mu, fine, and LS is there, LS is rho by 1 minus rho. If you plot this, you can take rho from 0 to 1 because rho is generally less than 1. So if you are plotting this rho from 0 to 1, then you can see this curve is almost converges towards 1, and here ls, you can see ls is from 0 to 100. So this is just a convergence. This plot shows the I'm taking one example to show this model. So assume a drive-up window at a fast food restaurant. Customers arrive at the rate of 25 per hour. So the employee can serve one customer every 2 minutes. Assume Poisson arrival and exponential service rates and find out the solution of these questions. First, what is the average utilization of the employee? That means intensity, rho. Second, what is the average number of customers in line? What is the average number of customers in the system? That means ls, lq, ls. What is the average waiting time in line? W S or WQ? WQ. What is the average waiting time in the system? WS. What is the probability that exactly 2 cars will be in the system? That means probability P when your random variable T greater than equal to 2. Exactly 2 cars. So T is exactly equal to 2. So now first, what is the average utilization of employee? That means rho. So here lambda is 25 customers per hour and mu is हर 2 मिनट में कर रहा है, तो रेट क्या हो गया 1/2 मिनट्स. कन्वर्ट, क्योंकि क्वांटिटी तो सेम होनी चाहिए, आवर्स में है तो मिनट्स को आवर्स में कन्वर्ट किया तो 30 कस्टमर्स पर आवर का सर्विस रेट हो गया. यानी एक घंटे में 30 कस्टमर्स को सर्व करते हैं वो. ठीक, 25 कस्टमर आ रहे हैं एक घंटे में और 30 को सर्व कर रहे हैं. सो इंटेंसिटी इज लैम्डा बाय म्यू 25 by 30 and 0.8333. This is the traffic intensity and this value is less than 1. So obviously we are having a converged solution. Now the second, what is the average number of customers in line? So LQ, in line की बात हो रही है, so LQ is lambda square divided by this, substitute lambda and mu, so finally you are having 4.167. तो यानी कि more than 4 customers जो है वो हर समय लाइन में लगे हुए होंगे. This is the meaning. What is the average number of customers in system? So ls is this relation, substitute all these values 5. यानी सिस्टम में 5 कस्टमर्स ऑलमोस्ट रहेंगे, एक सर्विस लेता रहेगा और 4 ऑलमोस्ट आपके क्यू में लगे रहेंगे. Average waiting time in line. So here WQ. So using Little's formula, LQ divided by lambda, and LQ is already we have computed here. 4.167 divide by lambda. Lambda is 25. So ultimately 0.16767 hours. So इस hours को अगर 60 से multiply कर देंगे आप तो minutes बन जाएंगे. So 10 minutes, almost 10 minutes. What is the average time in system? System में कितना time लग रहा है? So basically this is WS, not W. WS is equal to LS by lambda. So substitute all these values. So 0.2 hours multiply करेंगे तो almost 12 minutes. Then last question, what is the probability that exactly 2 cars will be in the system? So since Pn का हमारा formula क्या था? Rho raised to the power n into P naught. So rho की वैल्यू है lambda by mu raised to the power n और P naught is nothing but 1 minus lambda by mu. वो सब्स्टिट्यूट कर दिया, ये हमारी इक्वेशन आ गए. इसमें n की जगह हमने 2 रख दिया एंड लैम्डा म्यू की रख दिया तो हमारे पास प्रोबेबिलिटी आ गया. यानी हर समय सिस्टम में 2 कस्टमर्स रहेंगे या 2 कार्स रहेंगी, इसकी जो प्रोबेबिलिटी है वो ये है 0.1157. I think you understand. First model is over. Now the second MS infinite FCFS यानी Poisson arrival, exponential distribution for service, S number of customers, S number of our servers, infinite is the capacity, and first come first serve is the discipline. Here these are the assumptions, same assumptions except this, there are S servers and infinite capacity. Then this is graphical, this pictorial representation of this model. Here S number of servers are there. Then mathematically, since arrival rate is lambda, and we are having S number of customers. Here in assumptions, service time are variable in assumption and independent, but the average is known. Now the service is variable actually. This is the difference. Previous में क्या था? Constant था. Here we are having a variable. So here that's why mu n is, and since we are having S number of servers, so S number of servers तक आपका डिपार्ट ये है आपका स्टार्टिंग में आपका 0 स्टेज था, एक कस्टमर आया, यू आर इन फर्स्ट स्टेट, अगर वो डिपार्ट हो गया तो आप अगेन 0 स्टेट में चले गए, अगर वो नहीं हुआ तो आप एक अराइवल होता है तो सेकंड स्टेट में चले गए। तो जब सेकंड स्टेट पे आप जाएंगे तब आपके पास, और आप अभी तक कोई डिपार्ट नहीं हुआ है, तो यानी 2 कस्टमर हो गए, दैट्स व्हाई 2 म्यू इज द रिपेयर रेट। ओके, सिमिलरली थर्ड में जब आएगा तो 3 म्यू हो जाएगा। सो दैट्स व्हाई देयर इज वेरिएबल्स म्यू, 2 म्यू, s माइनस 2 म्यू। सो क्योंकि s सर्वर्स आर देयर, तो s म्यू तक तो ये चलेगा, s स्टेज तक तो यही चलेगा। जैसे ही s+1 पे आप गए, क्योंकि सर्वर्स तो कांस्टेंट है, तो ये s म्यू ही रहेगा लास्ट में, s+1 म्यू नहीं होगा, क्योंकि सर्वर्स आपके ऐसे ही हैं, सर्विस वही आपको प्रोवाइड कराएंगे। सो दैट्स व्हाई मैथमेटिकली हियर लैम्डा n इज लैम्डा एंड म्यू n इज डिवाइडेड इनटू 2 पार्ट्स। एक जब आपका n जो है वो s तक जाएगा, एक विच वन, ये कैसे हुआ s म्यू? ये इसलिए हुआ क्योंकि आपके पास सिर्फ s ही सर्वर्स हैं। अगर आपके पास s+1 कस्टमर्स भी हो गए सिस्टम में, तो सर्विस तो आपको सिर्फ ऐसी कस्टमर्स, दैट्स व्हाई s म्यू विल बी द डिपार्चर रेट, ठीक है ना, दैट्स व्हाई। सो इसलिए आप म्यू n को 2 पार्ट्स में डिवाइड कर सकते हैं, एक जब आपका n स्टार्ट्स फ्रॉम 1 to s, other when your n is from s to s+1, s+2, s+3 and so on. So for first one your departure rate is n mu, for second one departure rate is constant s mu, वो हमेशा constant ही रहेगा s mu. So now again same formula is pn is there, and now find out p naught and pn. तो इसके लिए आप चाहे तो बैलेंस इक्वेशन ऐसे बना सकते हैं, you can use, or either you can simply use your this equation p1, p2, p3, pn and then finally substitute. So ultimately if you are taking this balance equation, so from 1 to s तक तो एक ही बनेगा, फिर s के आगे के लिए आपका डिपार्चर रेट s म्यू हो जाएगा। So different equations are there, so that's why balance equation into ये first for s up to s stage and then s+1th stage, here s म्यू is there, डिपार्चर रेट s+1 म्यू नहीं हुआ, ठीक। तो combined all, simplify this all the calculation जैसे हमने पहले किया है। So we are having this relation, yeah, PS is 1 by factorial s into lambda by mu raised to the power s p naught, and ps+1 is this relation. For s+2 state, s+j state, we are having these probabilities, and if you write down all this in a very concise form, so Pn is basically Cn into P naught, where Cn is nothing but, since we have divided the stated into 2 parts, one from 1 to s, another one is from s to s+1, so that's why here Cn is basically this lambda by mu raised to the power n divided by factorial n, and you can easily find out this Cn by using this, you can easily find out from here. So here Cn is this for states 1 to s, and then Cn is this value, lambda by mu raised to the power s divided by factorial s, lambda by s mu raised to the power n minus s, from s+1 to onwards states. Now substituting all, since the sum of all the probabilities is 1, so that's why just substitute there and then take p naught common, and finally you will have this relation 1 by summation of this, and 1 by this summation can also be written as this raised to the power, this summation as it is same summation raised to the power -1. And here steady state condition is that lambda, because when you are finding this summation, So there is a term lambda by S mu. So lambda by, since departure rate is S mu, so now lambda by S mu should be less than 1. This is the traffic intensity actually now. In previous case, traffic intensity was lambda by mu, because mu is also constant. Here mu is not a constant, this is a variable S mu. So that's why traffic intensity is now lambda by S mu, which should be less than 1 for steady state solution. So here Pn is again divided into two parts. One is from 1 to S, another one is from S plus 1 to onward states, and this is the relation. Now here LQ, this is the performance measure. LQ is the waiting time, LQ. So n minus 1 customers, since S servers are there, तो जब n number of customers system में होंगे, S servers होंगे, तो waiting कितने कर रहे होंगे? n minus S. So n minus S into Pn we have already evaluated. So क्योंकि हम क्यू में निकाल रहे हैं, तो that's length of the queue, L. So length of the queue है, so obviously your n starts from S, क्योंकि S server में तो already लगे हुए होंगे. कोई आपके S plus 1 से या S से आप मान लें, S से start होगी, तो that's why n starts from S, then infinite, and then just replace n minus S as J, which is shown in this box. So n minus S is J, so that's why J P S plus J, and now J starts from 0, because when you put n is equal to S, then your J will be 0. So that's why J is 0 to infinite. So now using this simple calculation, finally we are having LQ is equals to rho raised to the power S plus 1 S minus 1 factorial into S minus rho raised to the power 2 P naught. Now next to performance measures, the LS and WS. Since we have already find out this LQ, so this relation LQ, so now using this and this formula, LS is equals to LQ plus lambda by mu. LQ is this value which we have already evaluated, plus lambda by mu. So this is LS. Similarly, WS is LS by lambda. So LS we have already evaluated. So now divide this LS by lambda. So you are having WS, this relation. यहाँ तक कोई doubt है आपको? ठीक है? Now WQ, using Little's formula, WQ is nothing but LQ by lambda. Q we have already evaluated, so that's why just substitute it and divide by lambda. So finally we will have WQ. And now probability that an arrival has to wait. Wait कब करेगा वो? Since there are S servers, तो जब wait वो तब करेगा जब number of customers जो है S plus more than S होंगे. So that's why n is greater than equal to SO. So this will be the sum of probabilities, all the probabilities when n starts from S to infinite. So substitute Pn. Here Pn is basically from this formula. You can use this second Pn. Why? Because your n starts from S, more than S, second category. So you can use second formula. So just substitute this value, second formula, and just take the summation. Ultimately you are having a geometric series and find out the solution. Yes?
What is the difference between waiting time for the queue or waiting time for
system?
For a customer, what is the difference?
डिफरेंस ये है कि जब आपका सर्विस जो सिस्टम वाला है उसमें जब वो सर्विस ले रहा है वो भी काउंट हो रहा है, और जब वो क्यू में लगा हुआ है सिर्फ क्यू में, सर्विस वाला काउंट नहीं कर रहे हैं.
तो टोटल वेटिंग टाइम
भाई आपका सर्विस कहाँ से स्टार्ट होता है? जैसे ही आपने एंटर किया और जब आप डिपार्ट किए, वो टोटल सर्विस का टाइम आपका लगा. लेकिन अगर आपको सिर्फ कहा जाए कि क्यू का ही निकालना है, तो जो सर्विस वाला है वो काउंट नहीं करेंगे.
टोटल वेटिंग टाइम सर्विस प्लस.
हाँ बिल्कुल. Now this is the example. Many early examples of queuing theory applied to practical problems concerning tool cribs. Attendants manage the tool cribs while mechanics assumed to be from an infinite calling population arrive for service. Assume Poisson arrival at rate 2. So Poisson, that means lambda is 2. This mechanics per minute and exponential distributed service time with mean 40 seconds. So mu is basically 40 seconds here. So if you find out this, so lambda is 2 per minute and mu is this 40 per second. So since both should be in same scale, so mu is 60 divided by 40. 60 is the hour. वहां पे आपका मिनट सेकंड्स में दिया हुआ था, मिनट्स में दिया हुआ है तो मिनट्स में कन्वर्ट करना पड़ेगा, तो 60 से उसका पहले आप रेशियो बनाएंगे तो 1/40 एंड मल्टीप्लाई बाय 60 क्योंकि आपको मिनट्स में कन्वर्ट करना है, सो 3/2 पर मिनट, both are now per minute, lambda as well as mu. And now since the now here अगर आप इन दोनों का रेशियो निकाल लेंगे तो रेशियो क्या बनेगा, लैम्डा बाय म्यू. लैम्डा क्योंकि अभी तक आपने देखा होगा इस लिखा गया है कितने सर्वर्स हैं, सर्वर्स के बारे में कोई कुछ नहीं बताया गया, ठीक. तो कितने को कैलकुलेट करने के लिए हम निकाला, so lambda by mu is basically 2 divided by 3/2, 4/3 which is greater than 1. तो कन्वर्ज हमारा सॉल्यूशन कब करेगा, when लेस देन 1 हो. तो लेस देन 1 तो तब हो सकता है जब मैं 4/3 को किसी क्वांटिटी से डिवाइड करूं. किससे कर सकता हूं, मिनिमम 2 से डिवाइड करूं. मिनिमम 2 से डिवाइड करूंगा तो कितना बनेगा, 2/3 which is less than 1. So that's why for this example at least you need 2 servers, at least 2 servers. Clear hai? So in this example we are taking row intensity is 4/3s. अभी था lambda by mu s हमने लिया था, so same value 4/3s. S is the servers and for this example we have selected servers. Clear हो गया सबको? So now P naught जो फॉर्मूला था उसमें हमने लैम्डा म्यू एस की वैल्यू सब्स्टिट्यूट की, तो फाइनली वी आर हैविंग 0.2. पी नॉट इज, तो इनिशियली कस्टमर्स होंगे नहीं होंगे उसकी प्रोबेबिलिटी है 0.2. कुछ पूछना है?
हमने अभी लिस्ट जैसे 2 लिया,
हाँ,
यहाँ पे लिस्ट ही लेना वो तो हम 1.5 से करते हैं, तब भी वो लेस देन
डेढ़ सर्वर, आप डेढ़ सर्वर्स जो है ये 1.5 आदमी तो नहीं हो सकता ठीक है ना. तो मिनिमम इंटीजर्स में चलेगा, पॉजिटिव इंटीजर्स में. तो द प्रोबेबिलिटी दैट ऑल सर्वर्स आर बिजी इन गिवन is given by this probability n is greater than equal to 2. So you can just find out the values. Then third is the limit time average length of waiting line of mechanics. So LQ we have already evaluated this 1.07 mechanics. So more than one आप कह सकते हैं in terms of integers, more than one mechanics जो है वो busy रहेगा, wait करेगा. The time average number in system is given by 2.5. Then average time mechanics spends at the tool crib is 1.2 minutes. More than 1 minute उसको spend करना पड़ेगा. And then average time spent waiting for an attendant is WQ is basically 0.533 minutes, 1 मिनट से कम. Now the third model MM1 and FCFS, Poisson arrival, exponential distribution for service time. Then one server is there, n number is the capacity of the space, and FCFS means first come first serve is the discipline. The third model here, single server and system capacity is n. So again lambda n is, since capacity is fixed now, इससे पहले वाले में हमारी capacity infinite थी, you can allow number of customers. Here capacity is fixed. For example the capacity of this room is fixed, इसमें एक लिमिट से ज्यादा लोग नहीं बैठ सकते. So that's why lambda n is basically lambda. Here n starts from 0, 1 to n minus 1 because you have allowed only n customers. In your capacity is n, so and there is no arrival after n. That's why n is when n plus 1 n plus 2 arrival rate is 0. This capacity is fixed and mu n is mu. This is constant. So this is the variation in this model. Based on this variation, this is the transition diagram. Here capital N is the capacity, and for n plus 1 state you can see there is arrival rate is 0 as well as departure rate is 0. Clear enough? Now again, using this formula Pn is equal to this, which we have evaluated earlier, you can find out P naught, and P naught is basically 1 minus rho. This P naught is 1 minus rho divided by 1 minus rho raised to the power n plus 1, and this is from geometric series. Geometric series में दो तरह के सम हमने पढ़े हैं, finite sum and infinite sum. This is finite sum because capacity is fixed n, so you have to take finite sum of geometric series, which is equal to 1 minus rho divided by 1 minus rho raised to the power n plus 1. And since here rho is not equal to 1, why? अगर 1 हो जाएगा तो क्या हो जाएगा? Define नहीं. In this relation, if this relation is basically rho is not equal to 1, for rho is equal to 1 you can take limit. लिमिटिंग केस लगा लीजिए, क्योंकि रो की वजह से वैल्यू आप 1 रखते हैं, 0/0 बन जाता है इधर, तो यू कैन टेक लिमिट and then you can apply the hospital rule, and finally you are having 1 by n plus 1. So here P naught is divided into two parts, one when your rho is not equal to 1, another one when your rho is 1. Rho is 1 means traffic intensity is 1, जितने लोग आ रहे हैं उतने लोग जा रहे हैं, and rho is not equal to 1 means there is a variation. So that's why Pn can be divided into two parts, one for rho is not equal to 1, another one for rho is equal to 1. So this is P naught, and since we know that Pn is nothing but rho raised to the power n, P naught, earlier formulation, so just substitute this. So P naught is since this, so multiply first relation by rho raised to the power n, you are getting Pn when your rho is not equal to 1. Similarly in second relation, 1 by n plus 1 multiply by rho raised to the power n, then you are having this Pn is equal to 1 by n plus 1 if your rho is 1. Since rho raised to the power n and rho is already 1, so that's why again same value 1 by n plus 1. There is no difference in Pn and P naught. Clear? Now your performance measure is LS, first measure. So again you can divide into two parts, LS based on Pn, because LS depends upon Pn and Pn depends upon rho, and rho is divided into two parts, rho is not equal to 1 and rho is equal to 1. So again that's why LS having two forms, one relation for rho not equal to 1. So this is the summation from 0 to, now capacity since finite, in previous cases we have kept taking infinite capacity, so summation is from n starts from 0 to infinite. Here capacity is finite, so that's why sum is from 0 to n, so n Pn, and since rho is not equal to 1, so you just substitute first relation for Pn, and then finally taking the finite sum, ultimately you are having this relation. Then when rho is 1, so just substitute Pn using second relation 1 by n plus 1, and then again take finite sum, then ultimately you are having n by 2. So now combining all these two cases, so LS is basically this one, for first one is for rho not equal to 1, second one for rho is equal to 1. यहाँ तक बताएं पहले आप, clear है ना? Now LQ, because single server is there, so अगर n number of customers किसी time पे हैं तो क्यू में कितने होंगे, n minus 1, so n minus 1 into Pn. Now put n is equal to 1 to n because finite capacity is there, so take this sum, so ultimately you are having LS is equal LS minus 1 minus P naught. ठीक है, फर्स्ट इक्वेशन. सो 1 माइनस पी नॉट कैसे आया बता सकता है कोई? n माइनस 1 को फिर दो हिस्सों में ब्रेक करें, n इंटू पी एन इज द फर्स्ट समेशन, 1 पी एन इज द सेकेंड समेशन, फर्स्ट समेशन इज नथिंग बट एल एस, बट माइनस दिस पी एन, यहाँ n स्टार्ट फ्रॉम 1 टू n है, टोटल समेशन होता है प्रोबेबिलिटीज का 1, तो इसमें सिर्फ पी नॉट नहीं है, तो 1 माइनस पी नॉट कर लेंगे तो ये रिलेशन आ जाएगा, फर्स्ट इक्वेशन. बट फ्रॉम लिटिल्स फॉर्मूला LQ is basically LS minus lambda by mu from Little's formula, which is represented by here question number 2. If you compare 1 and 2, if you compare, then obviously lambda by mu should be equal to 1 minus P naught. But interesting fact is that 1 minus P naught is not equal to lambda by mu. Why? Logic is already given here. Because the mean arrival rate is lambda as long as there is a vacancy in the quiz and is 0 when the system is full. Arrival तो तब होगा ना जब क्योंकि कैपेसिटी आपने फिक्स की हुई है. Arrival तो तब होगा. Arrival तब नहीं होगा जब आपका सिस्टम फुल होगा. That's why due to this logic, this 1 minus p naught should be not equal to lambda minus mu. So that's why you can replace this lambda. Actually problem is by lambda. So you can replace this lambda by lambda effective. Here represented by lambda EFF, which is effective arrival rate. What is effective arrival rate? I will show you again. So now just replace in this relation lambda by lambda effective. So lambda effective divided by mu is equals to nothing but 1 minus p naught. So you can easily find out lambda effective from here. So this is here. And now what is the meaning actually? So if you replace this lambda effective in the relation, then ultimately your modified Little's formula is here. Lambda is replaced by lambda effective. But what is actually meaning of lambda effective? So here we have graphically this pictorial representation of lambda effective is there. Initially there is a source, that means population is there. Arrival rate is lambda. एक कोई लगा तो कुछ लोग उसमें से लेफ्ट लूज भी करेंगे, लॉस्ट हो जाएंगे, क्योंकि हो सकता है कैपेसिटी फुल हो सकता है उन्हें पेशेंसी ना हो वेट करने का, वो भी लूज करेंगे. सो अल्टीमेटली वो जो चले गए हैं उनकी वजह से क्या होगा, आपका अराइवल रेट घट जाएगा. And that's why lambda effective is there. And finally this is the system. They will enter in the system. So lambda effective is basically represented by here. So now using this lambda effective, you can find out your modified Little formula. Lambda by ls, ws is basically ls by lambda. So here lambda is replaced by lambda effective actually. So that's why modified Little's formula is this for ws, as well as modified Little's formula for wq is LQ divided by lambda effective. And what is the meaning of lambda effective? We have shown here. Now I'm taking one example. Yes, sir. बस सर भैया सर आप सुनाए सर. अच्छा हम ना थोड़ा डायरेक्टर साहब ना 1:45 के आसपास कंक्लूड कर लोगे तब तक? ये तो सर हो जाएगा विद इन 15 मिनट्स ही हो जाएगा. ओके हाँ, मेरा लास्ट मॉडल चल रहा है मेरा. अच्छा उसके बाद फ्री हो जाए. हाँ बट चलिए मैं उनको 1:45 के करीब कह रहे हैं. हाँ हो जाएगा सर, इजीली, वेरी इजीली हो जाएगा. इसके बाद क्वेरीज वगैरह भी लेंगे तो 1:45 तक आप बिल्कुल हो जाएगा कंक्लूड. आई विल कॉल हिम. यस सर. वो कहते हैं मैं कभी बाद में जाऊंगा. अच्छा अच्छा ठीक है, मेरे सर उनसे मुलाकात हो जाएगी तभी मुलाकात. हाँ तो बाकी काम ये कर लेंगे. ठीक है ठीक है. और बढ़िया आप मिलके जाना मेरे को. अरे बिल्कुल सर. So this is the example MM1 and FCFS. Here example is patients arrive at a doctor's clinic according to Poisson distribution at a rate of 30 patients per hour. The waiting room does not accommodate more than 9 patients. Examination time per patient is exponential with mean rate of 20 per hour. So here lambda is basically 30 per hour, and this repair rate mu is basically is 20 per hour. Already given to examination time per patient is exponential with mean rate of 20 per hour. So that's why mu is 20 per hour, and capacity is 9 already given to you. So you can easily find out rho. Rho is lambda by mu. This is 30 by 20, 1.5, which is not equal to 1 again. Fine, which is not equal to 1. So you have to divide. So the probability here is the probability that an arriving patient will not wait is given by P naught is basically this. So here rho is basically 1.5. Just substitute this value to 0.0088. That's why we are having, since our rho is basically not equal to 1. That's why we are having this effective. So lambda effective is mu into 1 minus P naught. Just substitute all these values. So 19.8235 is the effective. So you can see here in starting your lambda is 30. Your lambda is 30, repair is 20, and effective one is 90, which is less than 20, क्योंकि 20 डॉक्टर्स देख सकता है 20 पेशेंट्स पर आवर, और जो अराइवल रेट है वो 19.8 का है. सो दैट्स व्हाई देयर विल बी नो कंजेशन. एक्चुअली अगर आप म्यू लैम्डा 30 लेके चलते हैं तो कंजेशन हो जाएगा, अगर आप लैम्डा इफेक्टिव लेके चलेंगे तो कंजेशन नहीं होगा. दैट इज द डिफरेंस. क्लियर है? नाउ lambda s is rho by 1 minus rho. This formula we have already established earlier. So just substitute all these values. So this is the average number of patients in the clinic is given by 7.1765. The next parameter s, which is modified Little's formula, ls by lambda effective. Substitute all these values. So 0.3620 r multiply by 60. So now in minutes 21.72 minutes. तो इसका मतलब क्या हुआ, एक पेशेंट को वेट करने के लिए कितना टाइम लगेगा, 21.72 मिनट्स. द एवरेज नंबर ऑफ पेशेंट्स इन द क्वी, तो क्वी में LQ इज इक्वल टू LS बाय दिस सब्स्टिट्यूट करेंगे तो फाइनली यू आर हैविंग 6.1853. यानी सर्विस को जोड़ें और वेटिंग को जोड़ें तब जाकर आपका कितना बनता है 21.72, और सिर्फ क्वी को जोड़ें तो 6.18, यानी मोर देन 6 मिनट्स उसको सिर्फ वेट करना पड़ेगा, उसके बाद उसकी सर्विस स्टार्ट होगी, यानी डॉक्टर उसको देखना स्टार्ट करेगा. द एक्सपेक्टेड वेटिंग टाइम ऑफ पेशेंट इज इन द, नहीं एक्चुअली दिस 6 इज द लेंथ, एक्चुअली मोर देन 6 इज द लेंथ, टाइम इज हियर WQ. सो टाइम 0.3120 आवर्स और मल्टीप्लाई बाय 60, सो अल्टीमेटली 18.72 इज द मिनट्स, यानी उसको क्वी में कितना वेट करना पड़ेगा, मोर देन 18 मिनट्स. Now the last model, MMS and FCFS. That means there are S number of servers and capacity is N. So based on assumptions here, since Q is there, क्योंकि हम उसी के लिए तो मॉडलिंग कर रहे हैं, so capacity should be greater than number of servers. अगर capacity कम होगी तो फिर तो वहां कोई Q ही नहीं होगी, किसके लिए मॉडलिंग कर रहे हैं हम. So that's why S is less than N, and obviously server जो है वो एक से ज्यादा तो होगा ही होगा कोई. So S should be greater than 1. Now based on this, here lambda n is this, because capacity is now fixed. Similarly, क्योंकि servers भी fixed हैं, so again mu n is divided into two parts, one from 1 to S minus 1, another one for S to S plus 1. Similarly, lambda n is again divided by into two parts, one from 0 to n minus 1, another one from n to from the ongoing states. And this is the transition diagram. Here S comes first because S is less than N, because S is less than, server is less than total capacity. That's why state S comes first and state N comes last. Next, PA naught, and again since your lambda and mu divided into 2 and 2 parts, so that's why there is P naught inverse is again divided into two parts. One is this first bracket and another is the second bracket. So this is P naught inverse. Substitute this P naught into the Pn formula, then finally you are having Pn, and solving for LQ, Q length. So Q length is, since there are S servers are there, so at so this expected value of this LQ is N minus S into Pn. Substitute all these values and finally you are having this relation. Here rho is basically lambda by mu s, because there are S servers. Similarly, LS, length in the system, is this. The final formula is here. Effectiveness we have already established. What is the meaning of effectiveness is there. So we have used this effective arrival rate, and here effectiveness is different from the previous model. In previous model we are having only single server. Here we are having S number of servers. So that's why effectiveness is defined by this relation. Lambda effective is mu into this bracket quantity S minus summation of this. Due to, because in previous we are having single server, here we are having S number of servers. That's the difference. Here waiting WS is modified, little formula is same formula, but a lambda effective is different. WQ is LQ divided by lambda effective. And now we are taking beauty salon has 2 barbers and 6 chairs to accommodate waiting customers. Potential customers who arrive when all the 6 chairs are full leave the saloon immediately. Customers arrive at the saloon at the average rate of 10 per hour and spend an average of 10 minutes in the barber's chair. The arrival process is Poisson and the service time is exponential random variable. So here lambda is basically 10 per hour, mu is 6 per hour, and there are two, actually you can see there are there are 2 barbers, there are 2 servers actually. So S is 2, capacity is 2 plus 6 है ना, 2 plus 6 8, and rho is lambda by S mu 5 by 6. So substitute all these values. Finally P naught is 0.1153, then lambda effective is 9.4632, and LQ is 1.5864. Similarly WQ is 0.1676 R. So multiply by 60, so you will have this 10.0562 minutes waiting करना पड़ेगा उसको कुई में. Similarly, the expected number of customers at the saloon is given by LS using a modified Little's formula. This is 3.1636, and the expected time at a customer spends at the saloon is given by this WS, and this is 0.3343 R, और minutes में convert करेंगे तो 20.0580 minutes. And last slide is basically this is a poem which is written for waiting. Everyone is just waiting. So this is a poem, and last is thank you. If you are having any question, then you can ask.
So can I ask a question apart from this topic?
Apart from this, you can ask that question later on. This is better because this session is devoted for queuing theory. That's why. देखें कोई है ऑनलाइन? JSS Academy Noida. If is there any JSS Academy Noida, is there any query?
Hello.
Yes.
No query, sir. Thank you.
Okay, thank you. JIT Jodhpur, is there any query? JIT Jodhpur, is there any query?
No query.
JIT Jodhpur, is there any query?
Hello, sir.
Yes.
No query, sir.
Okay, thank you. Thank you. The Institute and Engineering and Technology Alwar, is there any query? Is there any query from?
Hello, sir.
Yes.
Sir, no. Thank you.
Okay, thank you. Thank you. Then PVP Siddhartha from Vijayawada, is there any query?
Yeah, yes, sir. Sir, when we have 2 servers and customers are waiting in the line, sometimes customers may change their lines.
Yes.
How to handle that type of model, sir?
Actually, that type of model is basically based on the, yes, you are asking a good question, but here we have discussed only single server and simple. You can see my starting slides where we have used, yes, here.
In the last model, we have discussed about 2 servers.
Yes. I reply you. Basically, we have used this type of service facility actually here. We have not used this type of. You are asking about this type of facilities, multi-phase. Yes. So we have not modeled that type of, because time is very limited here. So that's why we have not modeled that type of problems here.
Okay, sir. Okay, thank you, sir.
Okay, thank you. Next is Vidya Bhavan, Polytechnic College, Udaipur. Is there any query? Okay, thank you, thank you. Then RD Engineering College, Ghaziabad. Okay, and then Jaipur. Jaipur Engineering College. Is there any query?
No, sir. Thank you, sir.
Okay, thank you. Stop करें. Yes, yes, sir. Yes. आइए आइए. Connected है सर? Connected है. आइए.
एक आधा नहीं होगा ना.
आइए.
So there is a one announcement for all the participants at different centers. Validatory will be held at 2:30 sharp. So all the centers coordinators, they want to do all the preparations related to the validatory, including the chief guest. So time is 2:30 sharp. Any other? Hello. सबको message है? So we will meet. You are completed?
Yes, yes.
So we will meet at the validity function, and it is on at 2:30 sharp. Okay.
civil.
Basically, this idea of conducting the operation research, when I meet Dr. Komal, so I remember one thing in 2013 when I was in engineering college Bikaner. So I proposed one course to be conducted at Bikaner, and that course was for the optimization techniques. So I write a letter to Dr. Komal and a mail requesting to conduct this course in Bikaner. So then he was busy in conducting some of the courses, and that time I thought, what will be the content? Because optimization technique and or operation research is a broad area. It is a very interdisciplinary area. So there are so many topics, so many relevant methods, topics, algorithm, new methods are coming. So when I was deciding what the content should be in order to see what are the audiences, because audiences are basically from engineering colleges and polytechnic colleges. So I try to focus on the relevant topics which are relevant to the engineering teachers and polytechnic teachers. So we include from basic linear programming to network scheduling, then queuing theory, inventory theory, and then Markov process, stochastic process. That is what I have done. I have tried to all include all the areas. So that is what I think.
So ICT, it is your first experience?
Yes, it is ICT. It is my first course in this year, in 1 year. And
so how was your experience first? Normally you are teaching in the class, mathematics.
It was very good experience, sir. Even though I have lots of things to interact with the center students, and earlier when offline course, I was just interacting with these teachers. Now we have so many centers, so I have more audiences are there. Even many suggestions come from the Noida JSS Academy and this PVP Siddharth institutes. So it is good experience to me. Even I like to conduct more and more courses on ICT, but the one thing which I want to share, that there should be some rules so that the teachers at different centers be there in the classroom. So I follow some strict rules so that they become present there.
So please convey us what those strict rules are. Actually, I framed one committee yesterday for making these ICT programs more effective. Normally what happens, some 30 teachers are getting registration, but end of the program there may be 10, 15, like. So some of them may not be very serious. One reason for that one is our contents may not be effective, our teaching may not be effective. Second one, because in the institute many assignments teachers are having, principal is saying now you go for examination duty, now you go for another class. There may be one of the reasons also. So whatever measures you people are suggesting, you are taking, please convey to us so that the effectiveness of these programs can be improved.
Even it is not only for ICT courses, even the manual courses we are conducting, same thing happens in that also.
Oh.
We will have a very few teachers present in the course.
Oh. Actually, no, in our case, when we are conducting training programs here, particularly in contact mode, no, then that issue is not there, because every hour the teachers are changing, their attendance is being taken.
Yes,
in that case, there is no issue. But when through ICT, when we are conducting, so one excuse they are having, sir, other assignments also we are having regularly, we may not attend. Professor Bhuta Singh is the dean in Punjab Technical University, is looking after distance education. Even when we were trying, sir, when we were having contact with PTU in initial stages, That time our target was that some of your distance education courses will be running through this ICT model. What we people are doing now, 6 centers are connected from here. Even it can be 20 also. And this year, we in our operation plan, we have decided that in some of the programs, we'll be connecting 100 centers. 100 centers
We also
simultaneously.
need, like, suppose we have a PCP program for distance education programs. So instead of having a teacher in all the classrooms, we have a one studio
Yes.
in the university.
9 PCP centers we are having. 9 centers we are having only at one center, and even teacher can be at NITTTRCHD Chandigarh also. There is no need to have in those centers. From here we can deliver. Students can listen us, the notes, everything we can give, and whatever is delivered from here, it is available now on YouTube. Even if some of the students are missing the classes, those videos are available on YouTube. They can and take the benefit of that one. And when we are connecting them, these centers, when we are connecting them, one option can be video conferencing. But video conferencing is a very costly affair. Costly affair in the sense they'll have to have this video conferencing equipment for which at least they'll have to pay 2 lakh rupees. Then connectivity which is needed, the internet connectivity which is needed, that is at least 1 Mbps dedicated lease line they'll have to have. Then only we are able to connect. So in initial phases, we were connecting through this video conferencing mechanism, but it was difficult, and only we were having 4 or 5 video conferencing equipment. So suppose we are connecting B2 Jalandhar campus. So our team used to go, they were taking video conferencing equipment from here, they were installing there, and then it was being connected. Then after 7 days, it was moved to another institute. So it was difficult. So this team of students who are working here for this purpose, I requested them that you please find out the mechanism where post is not involved in ICT, and even the connectivity, someone is having dongle connectivity suppose. If even that institute can be connected, because in our country the biggest challenge which we are having, we don't have good infrastructure. Huge number of institutes we are having, thousands, lakhs of students are registered, and teachers are available, but we are unable to connect them, particularly through ICT. Many of the polytechnics in the country, even they don't have laptop. They don't have laptop. So for connecting them, they let to have laptop, they let to have Google connectivity and this dongle connectivity, and through social media we are connecting them. The centers which are connected from us, they don't have any infrastructure at their end. They are having laptop, they are having dongle connectivity, or if it is 1 Mbps, then it's very good. The views which is coming from us, the views which is visible to us, it is through laptop camera. Okay. No separate camera is there. And when they'll be asking questions, the teachers, their views which is coming, it is coming through laptop camera. And when they're asking questions, they are using laptop mic. No additional infrastructure is needed, nothing, no special, it is only classroom. It's only classroom that is being used by them. If some good lighting is there, then certainly their faces will look brighter and it will be better. Otherwise, no additional facility is needed. And benefit of this connection which we have got, and 3.5 years back when I joined, that time our capacity was to train around 4,000 teachers in a year, and that was in contact mode. After my joining, I discussed with my faculty members that how can we can increase our reach. Our target is to reach up to the remotest corner of the country in a village. If some polytechnic is there, some engineering college is there, we want to connect that institute. And this effort of this ICT through this Google Hangout we have started 2.5 years back. Now our capacity, yesterday we were having our operation plan meeting, our capacity has become around 20,000 teachers. From 4,000 to 20,000. Around 15,000 teachers, then 3,000-4,000 students also we are connecting, and particularly for communication skills. So our capacity has become 20,000, and cost of training has gone down. Earlier teachers used to come here, we were paying TA, DA, everything, stay, everything. Now that has gone. The teachers are in their institute at 10 o'clock. We are starting our training program. Before that, they are engaging their classes. At 4:30, we are closing. After that, they are doing their family job. So their productivity has gone up, their efficiency has gone up, and on the institute, the load which we are having on infrastructure, that load also it has gone. So that way, it is very useful. And in the next year, our planning is by 2017. Our planning is in a year we should be able to train around 1 lakh teachers. That's our target. इतना बड़ा सा टारगेट हमने जो है लिया है. अब मैं आप लोगों से ये पूछना चाहता हूँ, you are in contact mode, then we'll be connecting other centers. What were your expectations and when you came to this institute? How many teachers are from this region, Punjab, Haryana, Chandigarh? You are from this region? Haryana, Punjab, US, Meerut, Ghaziabad, Gwalior.
MP, हिमाचल. कोमल तो हमारे यहाँ फैकल्टी थे पहले. So in place of coming from Gwalior to here, it's a huge burden now. If we could have connected you from there itself, है बड़ा यूजफुल होता. तो ये प्रयास हमने जो है किया है. अब मैं आप लोगों से एक चीज ये पूछना चाहता हूँ कि ये जो अपने जो ऑपरेशन रिसर्च का 5 दिन का प्रोग्राम किया, आप लोगों से यहाँ आने से पहले व्हाट एक्सपेक्टेशन यू हैड इन योर माइंड एंड what was your experience in this institute, not only in this training program, even your stay facilities, ambience, teaching, safety, regularity, behavior of the people, that's again the part of your training. ट्रेनिंग का मतलब ये नहीं कि मैथमेटिक्स पढ़ाना सिर्फ क्लास में सीख लिया और बाहर आपको दुनिया का कोई पता नहीं है. what these institutes are doing, what are the specialty of these institutes, why they are means known, what is the reason for behind that one. So at least 1-2 participants I would like to have that input from your side, and then we'll be connecting other centers. कौन बताना चाहेगा? चलो बताओ, आप बताओ.
सर ये जो यहाँ का environment है, that is
Can you come to this side because other teachers can also listen to you. Please come to this side.
I am Pinky from Government Polytechnic Jhajjar, Haryana. I am also doing ME from NITTTR in Electronics and Communication Department. My personal experience is कि जैसे यहाँ पे आती हूँ तो उस टाइम पे जो 6 आवर्स का वर्क होता है वो यहाँ पे 2 घंटे में ही फिनिश हो जाता है, क्योंकि यहाँ का जो एनवायरनमेंट है दैट इज पीसफुल एज वेल एज ऑल द फैसिलिटीज लाइक इंटरनेट. These all facilities are available to us. Thank you.
खाना वगैरह कैसा है यहाँ का?
सर अच्छा है.
अच्छा है?
Yes sir.
मैस में खाया नहीं खाया?
खाया है सर.
So you are registered here for your modular intake.
Yes.
हमारा मोडुलर भी है, समर विंटर में टीचर कोर्स वर्क करने और कोई 3.5 साल में पूरा होता है वो इंटेक.
ये 1% उसे वेट करते हो.
दो समर में 2 विंटर. 35 में
आइए कम फॉरवर्ड.
चलो हिमाचल से आपका क्या कहना है?
टेल क्या लिमिटेशंस, क्या आपको कमियां मिली हैं?
इस कोर्स के बारे में बताओ, आपको कैसा लगा यहाँ पे? हाउ इट विल बी यूजफुल इन योर टीचिंग?
Hello everyone, myself Abhishek Dwivedi. I am from Himachal Pradesh, from Himachal Institute of Engineering and Technology, Shahpur. Now these seminars and these programs are always helpful for the teachers, the academicians, and we are very much thankful for this organization that they are conducting like these programs. As far as ICT mode is concerned, I am also trying that our center should be connected with these institutions so that the students or teachers there, then they can be also benefited. But the criteria in these institutions in which we are serving, we have very less speed of internet, we are very much less facilities in infrastructures. So for getting these facilities, we are trying hard to for our managements that this facility can be provided, that we can contact with these our students. Sorry, our teacher can be also contacted with these programs.
अच्छा, ये जो प्रोग्राम था इसके कंटेंट्स आपके ऑपरेशन रिसर्च, व्हाट इज योर सब्जेक्ट?
Sir, myself is mathematics.
Mathematics. So you are teaching mathematics. Already you are knowing operation research. After doing this program, how your effectiveness will improve?
My effectiveness will improve. I am doing this course after 4 and 5 months. I have done this course 4 and 5 months before, and doing this course again. Okay. And my the fact of this course is shown in my teaching. I have improved a lot from getting this training here. My students are getting more knowledge from me, which is already missing in many concepts. Thank you, sir.
Sure.
Thank you.
So can you connect some 1 or 2 institutes? Are you able to?
Good afternoon, sir.
Good afternoon.
Sir, it's glad to see you, sir. After a long time, we have been there for communication skills workshop, sir.
Oh, good. Okay. So how do you find our transmission? Okay.
Sir, yes, sir. Technical part and academic part is very good, sir. There are no flaws in each and every aspect of the workshop, sir.
Okay. How many participants?
8 participants, sir.
How many?
8, sir.
Eight. All are from background?
Yes, sir. All are from the same college, sir.
Okay. So, can you suggest some of the improvement in the program? Because the contents you are saying it is good, your quality of transmission is good, but always there is chances of improvement. Any specific area, any specific topic you would like to suggest us so that next time when we are conducting the program, we have a better use of our
Yes, sir. Sir, actually, I wish to say only certain subjects are being focused, sir. Suppose if we put a letter or a request to you, then would you allow us to have a different kind of workshop, sir, like thermodynamics, something related to thermal engineering?
आपका नाम है?
Monica, sir.
Monica?
Yes, sir.
Monica, just you let me know our web portal, NITTTR Chandigarh Techno, and this NITTTR CST.ac.in. When you
Okay.
are our web portal, there is our web portal, operation hours is available, and it is for year 2016-17. In that, around 300 programs are there which are conducting in a year.
Yes, sir. Yes.
Every area, not only technical side, even non-technical, education technology, education management, entrepreneurship, curriculum, rural development, many areas are there. Just you people will have to select the program and will have to convey in advance 7 days before that in this program you will have to connect with your team.
Okay.
And you are getting, you are paying for your coordinator, you are paying your estimate. So, the benefit of the benefit of our expertise and this mechanism, this ICT mechanism, more or less it has been proved that it is very effective, it is useful, and just yeah, patient is so your views very clear transmission, but better than this. So, just you are making the home apartments and select some of the whatever you do. And even some of the people may not be opening the car. If it is there that type of people according to the requirement we can conduct it. So don't hesitate, be in touch and communicate us after taking decision at your institute level.
Okay.
Thanks.
Thank you, sir. Thank you so much.
Jaipur. Hello. Hello.
Yes, sir.
Okay. So how do you find this program? It's Director Chandigarh. Good afternoon.
Good afternoon, sir.
How was the program?
Sir, program was good and a little bit is not audible. Hello.
This time we are not audible, or during program our voice was not coming.
Right now, not audible, sir.
Hello.
You are getting?
Yes, sir, but it is kind of echo is.
Okay. Okay. Just whatever you are receiving, please convey to me. How do you find this program? 5 days you attended. How do you find? And particularly shortcomings of this program.
Sir, everything was good, sir. Actually, we learned a lot from NTTR this program. We are 27 participants currently, sir. But it is not for technical education. It is also we gain that we learn from all experienced teachers also how to teach, and the teachers who is using examples also. These are very beneficial for us, sir.
All 28 teachers are from mathematics background.
No, sir, no, sir. Mechanical and civil.
Okay. That's very good. Very good. Okay, best wishes.
Okay, sir. Thank you, sir.
Any other center if you can connect? जहाँ पे है? चलो, no problem. At least we are having idea of this one.
Some idea.
चल. So best wishes, Dr. Lachwani. It's a wonderful work. Komal, you are also, it's your first experience as far as this ICT is concerned. When you were here, that time this mechanism was not available. In the process of okay, okay. So thank you very much. Best wishes and hope in time to come you will be connected to this institute. So sir, best wishes. Doing wonders with a very small team. You are doing wonderful job. Please keep it up. कुछ कहना चाहेंगे?
I again say all the best. Because nowadays in many of the institutions, because there is no government funding, so to save the total cost even for classroom teaching also, many of the renowned universities in other countries also, like if the faculty is so much costly, like for their medical programs or others, then they use a common room for the delivery of a teacher that will be connected into 2-3 other rooms, the campuses of the same university in other places, so where there is a direct interaction program to the students, they can ask questions or even they can interact with the teacher. So that is one kind of, we can say, the viability of running education institutions, some education programs.
Very good.
So that way the NITTTRCHD is doing very good, because in the Punjab, I think this is the only institution where we have such type of programs where ICT is used for delivering the lecture, like for your FDP also. So that is one of the good initiative taken. So I wish all of you also, because as being teacher, you can spread this to your students. Even you can use this technology at your institutions also. So all the best. All the best.
Thank you, thank you, thank you.
You want to say something?
5 मिनट बचे हैं
Yes, sir.
Hello, good afternoon, all the participants and coordinators at different nodal centers. Good afternoon. Myself, Dr. B.C. Chaudhary. I'm professor and head Applied Science Department. And we have with us Dr. Komal. So he was interacting in the first half with all the centers. And Dr. Swami is coming soon. He is busy in some other arrangement. So I hope we met on Monday during the inaugural session, and then there were different sessions related to this program on operation research, and different experts from various universities or various other institutions. They delivered or interacted with the participants on specific topics, and I hope you all are benefited from these interaction sessions. And now we are here for this final valediction session of the program. Just a half an hour before, our director of this institute, Professor M.P. Punia, he interacted for short duration around 1 p.m. Unfortunately, all the participants were not there due to some administrative engagement. He could not come at time. As a result, he could not interact with all the participants, but we were having some short interaction with the few participants, and they gave their feedback regarding these programs and other limitations. And I know in this program, when we are running this through ICT, there are the difficulties because we are connected through the network, and technology, it is not always very reliable. So we of course we should use the technology, but on the other hand, we should also ready with the problems also. So now I will request coordinators from different centers and participants, and I hope at some centers some honorable guests are also there. So we will ask the feedback from different center one by one. So I will start with the first center. शुरू करते हैं, लिस्वानी साहब जब तक आते हैं, ठीक है? Sorry, मैंने ज़्यादा वेट नहीं किया है. So may I request the coordinator from JSS Academy of Technical Education Noida to come and give their valuable feedback.
Good afternoon, sir. Myself is Bharashar, coordinator at JSS Academy of Technical Education, Noida. First of all, I am thankful to you and Professor Krishnan Lakshman to conduct such a beautiful and knowledgeable program. All of the participants here, they have appreciated your program. They have learned various valuable techniques of operation research. Sir, my one suggestion or feedback or request, whatever you consider, I want to put forward is that what is a very wide topic. I understand. Can you, next time when you arrange this activity program on the same topic, can you give us a demonstration using certain software of operation research? That would be more benefit to us because it's an interdisciplinary subject, and some engineering branches people, they would like to use it using computers, the application part, I think. This is my humble request. We have with us our chief guest, Commodore B.K. Gupta. He is having an experience of 33 years in Indian Navy, where he was dealing with some diplomatic assignments, and then since last 17 years he has been attached to our academy, JSS Academy of Technical Education, as Chief Administrative Officer, and in this guidance our institution is making a lot of progress. May I hand over the mic to our chief guest? Good afternoon, everybody. I welcome you all on this presentation function. And at the outset, I would like to thank Professor Chaudhary and NITTR Chandigarh to give us this opportunity to conduct this program on operational research. It has been a proud privilege for the JSS Noida to participate in this activity, and I'm sure the faculty from this college, as well as the candidates from nearby colleges who have participated in this program, they must have been benefited. I wish we had more participants from the other colleges, but I think to make a beginning is not bad. We had 8 participants from every colleges and remaining from this college. I think it has been a good beginning, and I'm sure in future we will be able to do better. Now, being a man from the defense, I personally feel, not really, I personally feel, as a matter of fact, the history tells us that the operational research originated during World War I and World War II. I'm sure those who have read history probably will know when was World War I. World War I started in 1914, July 1914, and it ended sometime in 1918. And similarly, the World War II started in 1939, and it ended in 1945. I think we all, including myself, were not born at that time. I came into this world in 1946, that is after World War II. Now, what does operational research mean to us? And I not being a man from the academics, operational research, what it means to me is the optimum utilization of resources, information, and the manpower. Resources can be in different forms. Now, for example, when the operational research, which was used first time, as I said, in World War I, it was known by various terms. We call it appreciation of the situation. We call it appreciation of resources, may it be natural, may it be man-made, or may it be the battle equipment by the enemy, with the enemy, and then what is available to the enemy. The various opportunities which are available to the enemy and what is available to us. What is the best course of action for the enemy? What we think the enemy will do, and what perhaps is the best course for our own force. What it meant was, this is all the study of these things and analysis of the information which is available with us, basically what the operational research. After the World War II, in the next decade after the World War II, this operational research was adopted by the industry, it was adopted by medical science, it was adopted by science organizations. Now, further, today, this operational research influences every walk of our life. Even the government, the governance by the government, needs operational research. They need to study, they need to analyze the various resources available, the various courses of action available to them, and all this process is what perhaps, in my impression, is called the operational research. Of course, today there are mathematical models which have come up, and these models, they help you in analyzing and better analysis and optimum utilization of the resources available. I would like to thank the organizer, especially Professor Ansari, and then Professor Prashant with us, and all the participants those who have taken part in this program, and I am sure you have been benefited, and whatever you have learned here, you will further try to study it and also deploy it in your personal life. Thank you very much, and I wish you get more opportunities to participate in these kind of things. Thank you very much.
Thank you, sir. Thank you for your valuable comments. Now we move to the next center, that is JIET Jodhpur. JIET Jodhpur. Manoj Kumar is the coordinator at that place.
Hello.
Hello.
Hello. Good afternoon, sir.
Good afternoon.
Am I audible, sir?
Yeah, you are audible.
Sir, I am Manoj Kumar, local coordinator, lecturer in mechanical engineering department, and also pursuing ME from NITTTRCHD Chandigarh in modular course, 2014 batch. Program on operation research was fruitful for our faculty members. Different faculty members from various streams like MBA, civil, mechanical, applied science are participating in this program. And today, actually, sir, we have a collector of holiday in Jodhpur. Participation and there is no one chief guest we invite. The I would like to thank course coordinator Dr. K.C. Lachwani sir to develop a very good program from basic fundamental topic operation research to multi-level programming problems, and similarly they have on numerical session side by side. It is very wonderful program, and we enjoy, sir, and thank you very much, sir. We learn from different sessions, and we also, sir, introduce Marco process is very beneficial, and we learn something new.
So thank you. Now may I request you to just ask one or two participants to give their feedback.
Yes,
how they like this course and what improvement they want in future.
Yes, sir.
I want feedback from one or two participants also.
Yes, sir. Yes, sir.
Hello.
Hello.
Good afternoon, sir.
Good afternoon.
I am Jaswant Kumar Dave from JIT Jodhpur.
Okay.
So all the sessions was very nice, very good knowledge in the sessions was considered. But there is a problem, sir. Regarding the numerical problems, एक्चुअली सर जो क्वेश्चंस वगैरह हुए हैं इसमें जो टिपिकल प्रॉब्लम्स होनी चाहिए रिगार्डिंग ट्रांसपोर्टेशन प्रॉब्लम जो डीजनरेसी की हम बात वगैरह करते हैं ट्रांसपोर्टेशन के रिगार्डिंग वो क्वेश्चंस वगैरह कंसीडर आई थिंक नहीं किए गए हैं जो सेशंस हमने अटेंड किए उसमें हमें वो चीज़ दिखी नहीं तो अगर वो डीजनरेसी प्रॉब्लम्स वगैरह उसमें कंसीडर की जाती है असाइनमेंट प्रॉब्लम्स में डीजनरेसी वगैरह आती है उसमें अगर वो प्रॉब्लम्स कंसीडर की जाती तो लॉट ऑफ द पार्टिसिपेंट्स जो यहाँ इंटरेस्टेड है उन लोगों को इसके रिगार्डिंग नॉलेज मिलता और ट्यूनिंग थ्योरी की जो प्रॉब्लम्स वगैरह थी जो मल्टी चैनल ट्यूनिंग थ्योरी की प्रॉब्लम्स वगैरह थी जो आज की बताई गई सुबह मॉर्निंग में उसमें भी वो सर मल्टी चैनल वाला अपन कंसीडर नहीं कर पाए तो अगर वो भी उसमें कंसीडर होता तो आई थिंक जो नॉलेज इंप्रूव होता वो अच्छी बात होती बिकॉज दे आर द पार्ट ऑफ द ऑपरेशन रिसर्च प्रोग्रामिंग तो ये थोड़ा एक था कि वो प्रॉब्लम्स अगर कंसीडर होती तो अच्छा होता
Definitely. Next time these problem will be considered. I request Dr. Laswani to consider these problem. One more participant from JIT Jodhpur.
सर एक्चुअली वन थिंग और एक्चुअली कुछ प्रॉब्लम्स ऐसी भी है जो आपने कंसीडर नहीं की है कुछ चीजें ऐसी भी जो ओआर में आई है जो आप कंसीडर नहीं कर पाए तो अगर नेक्स्ट टाइम ऐसा कुछ सेशन हो तो रिमेनिंग जो चीजें हैं वो भी आप कंसीडर करते हो बेटर रहेगा हम लोगों को
ठीक है बिल्कुल
थैंक यू सो
Second participant.
और कोई अलावा नहीं है
So, Mr. Manoj Kumar, it's over from your side.
Yes, sir. Yes, sir.
Thank you for your feedback. And your feedback will be taken with utmost importance, and we will next definitely consider these problems in our next program. So now I move to another center, Vidya Bhavan Polytechnic, Udaipur. Who is the coordinator? Vidya Bhavan Polytechnic, Udaipur.
Yes.
Dr. Amit Mehta, good afternoon.
Thank you very much, sir, for including our Polytechnic as one of the nodal center. And I believe the Vidya Bhavan has already extended the invitation to Mr. Lachwani for expert lecture and orientation lectures for the faculty of the Vidya Bhavan. Am I right, sir, Mr. Lachwani?
Pardon, sir, pardon.
Hello. Can you hear me?
Now I.
Hello.
Yes.
You can continue.
What I'm saying is that probably Vidya Bhavan has already extended invitation to Mr. Lachwani for orientation of mathematics teachers of Vidya Bhavan. The course is really good, but there are certain suggestions when we conduct the courses on mathematical subjects, especially it deals with the linear programming or simplex method or stochastic methods or non-stochastic or optimization. It is very difficult to focus the content because a lot of mathematics is involved. We observed that sometimes there was no synchronization between what is there on the slide and what is explained on the board. So what I would suggest on behalf of all the participants that from next time whenever we conduct such type of courses, we should provide the study material in advance. They may be in the form of the lecture notes or some worksheets so that the faculty or the participants can do the exercise simultaneously. So what I would say that the focus was could not focus much, but we believe that from next time, if the study material is provided, if the worksheets are provided, and if the whole entire program is engineered in different way, the participants will be benefited more. Thank you, sir.
Thank you for very valuable suggestion. So we will next time we will frame some worksheets also, and reference material will also we will try to provide some reference material before start of this program. So how was the connectivity at your center? You are having problem on the first day?
Yeah.
It was okay throughout this week?
Yeah. It was on the first day.
Okay.
That was 2 hours. That was the internet connectivity problem.
Okay. So otherwise it was good for all the lectures.
Yeah.
So thank you, Dr. Mehta. Now we will move to another center, that is JEC Jaipur. JEC Jaipur, Mr. Jitendra Kumar is the coordinator.
Yes, sir. Good afternoon.
Good afternoon.
Sir, I am Jitendra Rai from Jaipur Engineering College.
Yeah, you continue with the feedback. Yes, you continue.
Yes, sir. The workshop was nice and all contents was also very good. And explanation and giving examples and solving problems is good of Lachwani, sir. Hello. Some contents are missing like game theory and inventory and like simulation. That was also important topic in operation research.
Okay.
Yes, sir. They must be included in next time. Yes, sir. And all participants are beneficial for this. But we have even that same time important LCM theory and simulation and inventory. Maybe time.
So
Thank you.
definitely we will try to include these topics next time. I hope connectivity was very good at your center.
Yes, sir.
I can see video is very clear.
Yes, sir.
So I request all the coordinator also to please fill the feedback form and send the feedback form duly signed by all the participants and attendance sheet to the coordinator well in time.
Okay, sir. Feedback form has been filled and attendance sheet also prepared, and
So,
then we have sent through email.
so thank you for your valuable suggestions. Now
Okay, sir.
I move to next center, that is PBP Siddharth Institute of Technology, Vijayawada, Andhra Pradesh.
Good afternoon, sir.
Good afternoon, ma'am.
Sir, here we are having a chief guest, sir, MCA HOD, sir, and he would like to address the audience.
Okay.
Good afternoon, sir. Sir, thank you for giving this opportunity to organize this event at our institution, sir. I'm the knowledge coordinator here, sir, knowledge center coordinator to organize this kind of events at our institution for various departments from NITTTR Chandigarh, sir. And regarding this operations research, some of the topics which are covered by you and your team members, which are more relevant to our area of computer science, which are connected to cloud computing, sir, towards multi-objective programming and multi-level programming, Markov process, and queuing theory. So these might be useful to our cloud computing area to solve some problems in the research aspects. Thank you, sir. Thank you for giving this opportunity, sir.
Thank you. Madam, do you have any other comments?
Sir, actually, our participants thought that if all the lectures were in Hindi, then it would be comfortable to all the participants, sir. We are from the south side, sir. Sorry, if it is in Hindi, not in Hindi, sir, if it is in English.
Okay. Yeah. So you also interacted with Dr. Punia also.
Yes, sir. Yes.
I was there. So any other feedback from the participants?
Yeah. Yes. I would like to invite the participants.
I want feedback from 1 or 2.
Good afternoon, sir.
Good afternoon.
Actually, all the sessions we enjoyed well and we got a good knowledge about the topics, sir. Actually, we faced some problem during Kamlesh sir lecture because it is most of the lecture is in Hindi. Otherwise, all the lectures are very nice and very informative, sir. Thank you, sir.
Okay, I want one feedback which you find was missing from in this program. Any one what was missing from the program?
We want more number of examples to be solved even in PERT, CPM and assignment also, sir. Markov analysis, multi-level programming, all those things also we want some examples to be solved.
Okay.
Thank you, sir.
We will take care in the next program.
Okay.
Any other participant from this center?
Good afternoon, sir.
Good afternoon.
So the total lectures are very informative, sir. But only the lacking thing is we want to do some more projects on operation research. So in that perspective, we didn't get any special information. But whatever the knowledge shared by you people are very, very useful for us at this moment. But in order to do the more projects on operation researchers point of view, we are lacking some information, sir. If possible, in the next sessions, you include that part also, sir. That is my request.
Okay. Thank you for your feedback. I request Dr. Swami to please include this part. Maybe some more case studies based on this part. So we will definitely add these in our next program. So thank you all the participants at Vijayawada Center. Now we move to our last center, IET Albert. IET Albert. I request the coordinator to raise for the feedback. IET Albert, Kumar, IET Albert.
Hello.
Hello.
Hello. Hello. Hello.
IET Albert.
Hello. Good afternoon, sir.
Good afternoon.
Sir, I'm Dr. Hello.
Yes, yes.
Sir, we have a guest for the validatory function, Dr. Sanjay Priyadasi. Hello. Hello.
Hello.
Hello.
You continue to audible here.
Yeah. Sir, good afternoon, sir.
Good afternoon.
This is Sanjay Priyadasi from IIT College, Ahmedabad. Hello. I would like to thank sir for providing such a wonderful workshop on the IST waste, and it was really helpful for us getting the knowledge of testing research, such that we were also teaching of mathematics. Instead of getting flavor of that, we can do some more research work as well in the mathematics. And we really need of today's research that industrial research is going on, so we can implement this concept in our research. Hello, can you hear me, sir?
Yeah.
Yes, sir. It was really helpful for us, and I would like to thank for this organizing this workshop.
May I request one of the participants to give feedback regarding the program? Any participant from your center?
Sir, it was very clear.
I want feedback from one of the participants. One participant from your center. Can he come and give the feedback? One participant from your center. Okay, if no one is interested, I'm thankful to all the participants, all the coordinators, and dignitaries at different centers for their valuable feedback and your interaction throughout these programs. And I hope we will continue with this type of program in future also. And your feedback from different nodal centers is welcome. All these comments will be incorporated in our future programs. Now I also we have some participants at our studio also. So I again request one or two participants from this classroom to give feedback on their experiences while sitting at this studio room. तो मेयर वन और टू पार्टिसिपेंट आपको कैसे लगा जहां पर और डिफिकल्टीज यू फेस बिकॉज यू आर सिटिंग देयर यू आर नॉट एबल टू सी एनीथिंग व्हाट इज गोइंग ऑन बताइए आप मैडम हैं कोई डिफिकल्टी नहीं थी हमारे लिए तो डिफिकल्टी जा रही है
I'm from CS department. My name is Garima, and it's my first training program, and it was a very experience for me, and lot of things I have gained from this program. And thank you and for giving me such a wonderful opportunity. Thank you so much.
Since you are from computer science department, you must have suggested some new softwares or other things to be incorporated in this program.
Sir, actually, there is one new technique in database systems. That's the Hadoop technology. So where actually I have attended one program in Hadoop technology. So I just want to join this program again and again.
We have procured one Lingo program that is also
mathematical.
Okay, mathematical. Lingo we are in the process.
Lingo में वो उसमें
But Lingo is part of this.
Lingo is a
Huh? So hopefully next time we have some software also. So any other participant? What we are closing? We are closing. और आइए प्लीज आप कुछ बताइए. आपने जाना है जल्दी. आप बताइए कैसे रहा आपका एक्सपीरियंस.
जाने का टिकट है.
बताइए. हाँ. आपको कंटैक्ट प्रोग्राम और इसमें से कौन सा अच्छा लगा दोनों में से? नेचुरली कंटैक्ट अच्छा लगा होगा, बट इसको कैसे हम बता सकते हैं? बिकॉज in the morning you listen to our director, so he has constituted a committee of 3 members because we know there are a limitation in this program. कुछ कमियां हैं जिनको हम दूर करना चाहते हैं. So any suggestion from your side कि इसमें से ऐसे होना चाहिए?
आईसीटी के थ्रू जो ये हुआ था, इसमें थोड़ा सा मॉडिफिकेशन की जरूरत है. कनेक्टिविटी की प्रॉब्लम की वजह से सारे सेक्टर से नहीं हो पा रहा. हमारे यहाँ भी लिंक हुआ था एक बार प्रोग्राम का, तो इतने अच्छे से कम्युनिकेशन नहीं हो रही थी. तो उसी में इम्पोर्टेंट की जरूरत है.
ठीक है. So thank you all the participants in studio and at different center for their feedback, and we will definitely your suggestions will help us to improve the program in future, and we are also, our team at network, they are also trying their best to improve the connectivity and make this program more and more interactive. Now I hand over this platform to Dr. Laswani again at the end to conclude this part.
Thank you.
Sir.
All the parts are at different steps. Okay. Yes, please.
Sir, our special thanks to you, sir, because you made the sessions very wonderful. The way you taught the lecture is awesome, sir.
Thank you very much. Even you give me the feedback, because I personally believe even best can be improved. So you give me the negative feedback so that I can improve.
No negative.
Huh?
Any limited?
Nothing negative, sir. Sir.
So
Actually,
We want.
some more examples. Only for your section, we were able to bring more of participants, sir. Even the students we have gathered here, sir.
Okay. So thank you very much for praising me, and thank you very much. So I this valedictory
feedback और उसका क्या दीजिए?
So I request all the coordinators and participants at different centers, and coordinator must ensure send the feedback form and their bills and all other material, the administrative material. Please send it to me at earliest so that we can process them. And thank you very much for all the coordinators for conducting this course on operation research through ICT mode. Thank you very much. Without your support, this program could not be successful. Thank you very much. Thank you very much, our HOD, Dr. B.C. Chaudhary. Thank you very much, Dr. Komal from Dhoni University. And today it is a special day. Dr. Komal is with us, and he has already served in this institute. So thank you very much. Thank you all. Thank you all the participants.
Thank you all.